Okay, how are you all feeling? A little louder. We did a practice test also. Online audience will think there's nobody sitting here because the cameras cannot show them, but I can assure you there are 10,000 people in the audience. So let's prove it one more time. How's everyone doing? Great. Nice. So everyone watching online, I hope you can hear me fine. If not, we'll get to know at some point. But let me start off with welcoming all of you to the third version of ADCx India. We started in 2024. I mean, the planning started in 2022. We then eventually ended up doing it in 2024. And then now we are doing it for the third version. So a quick question. How many of you have attended at least one ADC event? Show of hands. Nice. How many of you are attending for the first time? Nice. So a good amount of new audience. So really good to know that we are reaching out to more people. So the introduction is supposed to be done by me and Bobby Lombardi, who is the chair of ADC. He couldn't travel because he has to attend to family duties. So he has sent a very nice message to everyone, which I'm going to read. So Bobby, I hope you're watching. Please comment in the chat section of YouTube. And this is Bobby's message. Dear ADCx India attendees, my sincere apologies for not being able to join you this year, as I'm currently on holiday with my family. I want to extend my congratulations to Prashant and the entire ADCx India team for their hard work in creating what I'm sure will be a wonderful event. I'd also like to thank each and every one of you for your continued support of the global audio developer community. It's gatherings like these that keep innovation alive and help our community grow stronger. From the heart, I wish you a fantastic conference and the opportunity to connect with colleagues, both old and new. With much appreciation, Bobby Lombardi, Chair of Audio Developer Conference. Let's just give a big round of applause for Bobby. Just so you know, Bobby is like one of the strongest reasons why ADCx India's events happen, and I'll talk about that more in the conclusion. So a quick overview of ADC, because some of you are like first-time attendees. So ADC is the Audio Developer Conference. It's a not-for-profit event, and the conference is true to every sense of the term not-for-profit. Again, more in the conclusion, so stay tuned. The idea is that we bring audio developers, artists, creative coders all in one place so that we can collaborate and get to know more about each other and also learn in that whole process. So that's the main agenda that we have for ADC. Now, historically, ADC used to happen only in Europe, in London and Bristol. That's the main ADC event. But for the last 2 or 3 years, we have also experimented with ADCx style of events, where it's a one-day pop-up with short talks, like 18-minute duration talks, and then it allows us to reach more geographies and more areas and help people connect in that direction. So this year, by the way, we actually completed 10th year of ADC anniversary last year in November, so a round of applause for that. So this year, we have many events lined up, starting with ADCx India, which is happening today, right now, as you're watching on live stream as well. Then we have ADCx Copenhagen. Then we have ADC Japan. And then eventually, we have ADC Bristol, the main ADC in November. More on this in the conclusion. So a quick information about me. My name is Prashant, and I am an audiophile. But yeah, I won't do that joke here, but because I'm just warming up, so it won't land. And then if people don't laugh, I'll not feel good. Anyway, so I'm Prashant, and I'm an audiophile. I work as the CPO of a sound effects platform called Soundly, and I am a founder of my organization called Pacific, through which I'm trying to build audio communities, products, sonic experiences, and education initiatives. For today, I am hosting the ADCx India event with an amazing team who you will meet at the conclusion again. Let's quickly check what has been the journey so far. So when we did the first ADCx India event in 2024, we had an amazing turnout. We were not expecting it. We had more than 100 participants reaching out. And the agenda at that year was to establish this whole message. Let people know that, hey, there is something happening in India. Then in 2025, last year, we wanted to continue the momentum. But because we have lesser budget, we did a smaller gathering. So the numbers might be less, but the enthusiasm continued. So we tried to maintain the momentum, and it worked out really well. And this slide is yet to be made. 4 p.m. today. Please be here so you can be part of the picture for this year's event. Now, the agenda for today is very straightforward. First things first, there is a QR code on all of your ID badges. Scan it so you can see the schedule right away, so you'll know what's happening when. The talks will be 18 minutes long with 5 minutes for Q&A. There's a keynote which is 50 minutes long. If you are given this opportunity for Q&A, a microphone will be shared with you to ask your question. Please wait for the microphone to be on, then ask your question so that the live audience can also hear it. Again, like we'll have the group picture around 4 p.m. We have networking breaks, which will include some snacks and coffee and tea. We also have lunch, lavish lunch, really, really good. Don't miss it. And we have a sponsors booth outside, which is by Avid and Global Logic. You can check out their products, meet the team, and get to know what they are up to. More on the sponsors thing, again, in the conclusion. We actually have many sponsors this year. So Avid and Global Logic is one who have set up a booth. We also have Vinjay. Is Vinod from Vinjay here already? OK, so he's probably outside. So from Vinjay team, you will have Vinod, Deepak, and Tarun, who you can meet and get to know about what they are up to. They're doing some really cool stuff, and they are probably hiring as well, so definitely meet them. And then from Force United, there is going to be Ansh, who might show up a little later today. So after event meetup is also there. I hope you all have read the email. Did you read the novel that I wrote on email? All right, so OK, so if you have not read the email, please take your time and read through it because it has some information about the after-event meetup that we will do today. Have fun, make a lot of connections. Please don't hesitate to reach out to a random person and start talking. You see, it takes like few seconds to get comfortable, but once you're in the zone, nobody will mind you reaching out and talking. That's the whole point of being here. So make a lot of connections. Take pictures if you want, but please be mindful of everybody's personal space. If you're posting something online, use the hashtag AudioDevCon or ADCx India, and help us run the event on time. Now, one important thing, you all have been given ID cards with lanyards. Please wear them so that the BIC venue and our catering knows that you are part of the event. White lanyards means the volunteers and organizers. Yellow ones means they are speakers, and red ones means all the attendees. All right? Any questions so far? OK, it's not a very strong. Any questions so far? No. All right. Good one. Waiting for your keynote. So the last thing is, please be mindful of the cables running around. So if you step on any cables, we might lose the audio or the live stream, and we don't want that. So please be mindful of where you keep your foot. And with that, I think I'll not take any more of your time, and let's begin. Welcome again to ADCx India, and let's have a great event. All right, everyone. So our first speaker of today is Soham Korade, who is a programmer and musician interested in using computer to better understand and teach Indian classical music. He'll be giving a talk titled Raga as Data, Symbolic Music Representations for Analysis, Visualization, and Audio Tools. Please give a round of applause for Soham.
Thank you, and hi, everyone. I am Soham, and today I'll be talking about building tools for Indian classical music and how thinking in terms of different representations can help you design better systems. Yes. So I'm a software engineer at Walmart and a fresh graduate from IIIT Hyderabad last year. I have previously interned at Beethoven and Hotstar. I'm also an amateur musician and I play the keyboard, guitar, and the bansuri, which is the Indian flute. Outside of that, I spend a lot of time building tools around music, especially Indian classical music. So first of all, I would like to play a sample of Carnatic music for those who haven't heard of it. So this is an alapana in Raga Kapi. And if you have observed, there is no rhythm here. It's just a free-flowing exploration of raga. And notice how the pitch is continuous and the notes glide into each other, unlike Western music where you have discrete notes. And how the same note is never sung exactly the same way twice. So there is a subjectivity in rendition. So this expressive fluid nature is what makes the music beautiful. And it also makes it very hard to model computationally. So that is the core challenge that we will be keep coming back to in this talk. So in this talk, I'll walk through a few approaches that I explored. Think of it as a timeline of projects, each making different design choices. And it's all about Indian classical music and symbolic representations for those. So one of my earliest projects was something I called Swar Composer. So the idea was simple. I would enter North Indian classical music notation into it called Swarlipi. So I built a parser that could read the notation and play it back using MIDI. So it supported external MIDI players too, and we could visualize the music in a synthesia-like format. So the pipeline was simple. You write notation and the computer plays it back. So you get pretty visualizations also. And this is the next version of it. Because everything was structured in the previous pipeline, you can easily extend it. For example, adding a tabla track. So from a systems perspective, this is a modular pipeline where the first step is to parse notation. Second step is to map individual MIDI pitches to each swara. And third step is to add rhythmic structure to it based on the tala selected. And fourth step is to render audio and MIDI together. This all went well, but this kind of sounds boring because as audio developers, we naturally move toward audio and we like expressive renditions and rich renditions. So this is an example. What I built before. So you could enter classical music notation into it and it would play along with the tabla. And this is some of my different kind of approach where I used web technologies to build interactive instruments. On the left is a flute app. It uses multi-touch for finger positions. It's a mobile app. So you can keep all your 6 fingers on the screen and then blow into the mic. So the amplitude of the mic, the app detects and plays the note which you are holding. And if you blow harder, it will play the next octave as a flute should play. And in the middle, you have a hand gesture instrument. In this case, your index finger controls the pitch, and the camera tracks your movement. And the distance between index finger and the thumb controls velocity. So this is kind of a 2-dimensional expressive instrument. And on the right is a touch-based slider where you can move freely your finger on the screen, but the notes that are available are constrained to a raga. And sometimes in ragas like Desh, where the ascent and descent are different, the right side of the screen will be ascent and the left side will be descent. So even if you play freely and randomly, it sounds like the whatever you play is in a raga. So what I found interesting here was we can utilize multiple modalities like touch, vision, and audio, like I just showed, using everyday devices. So being on the web also make these apps accessible. These are all based on web technologies. But when we move from interaction to understanding, things get harder. So let's try music understanding using notation. So until now we have seen playback and interaction. So this third app of mine allows you to play the on-screen keyboard to enter notation. And starting with notation, it does something simple. It extracts n-grams from notation, which are just a sliding window, and matches against the database of different ragas. And the match with the highest count is the most probable raga. So this is a basic raga recognizer that I had made. And it works just through notation. Then we try the harder task of doing that through audio. So now the flow looks like first the audio waveform, which you will get through the mic or any audio file. And then you extract the pitch, so pitch detection, and you try to segment each individual note. And then using the notes, do the same thing that the previous pipeline was doing, which is pattern matching. But here we see an example. I'll show you how that worked.
झाकल्या मुठीत काही, झाकल्या मुठीत काही, गोड सुख राम देई, गोड सुख राम देई. दुःख तिमिर दूर जाई, दुःख तिमिर दूर जाई.
So as you saw, initially I played the original audio, and then later the synthesized detected pitch was layered on top of it, and then the original audio was removed. So this way we can check if the pitch detection is working properly, and we saw how the notes were segmented. But in this process, getting good results is not that reliable, because slight alterations in pitch can make note detection hard. And this is where things get difficult, because Indian classical music is not made of clean and discrete notes. So we have three main problems, which is continuous pitch, which means that one note flows into the other note seamlessly, so you don't know which note is which. And we have ornamentation on a single note, which is called gamakas. And we have variability, that is the same phrase can appear in many forms, depending on the person who is rendering. So even something as basic as what note is being played becomes ambiguous. And this leads to the first key takeaway that we have, which is audio is expressive, but it does not give you clean structure to do any analysis on, unless you do some high pre-processing. So the question becomes, can we work with a representation that already has structure, instead of trying to infer structure from audio? To answer that, let's look at different representations that we have. So in general, we can think of two kinds of representations, symbolic and acoustic. And the main difference is symbolic representations are already discretized and structured, and they are also easy to modify, whereas acoustic ones need a very specific pre-processing based on the task on hand. And descriptive notations and prescriptive notations are two types within the symbolic domain. And we generally see that the descriptive notations tell the performer exactly how to play. So there will be minimal difference across different renditions by different people of the same notation. And prescriptive notation only tells the performer what to play. So the final output will be subjective, which is largely the case in Indian music. So any composition that you have will be sung differently by different people. I just want to highlight that we have made a lot of progress in standardizing sheet music for Western music. Today, sheet music is not just an image. It is found in different formats like music XML, which represent notes and timing and expressions in a structured and machine-readable way. And that makes it much easier to analyze and build tools on top of it. But we really need something similar for Indian classical music. Before going further, let's take a look at how music information retrieval typically works in an audio domain. I have borrowed this slide from Ajay's keynote from last year. So most MIR pipelines start with audio and then try to extract structure from it. In the top, you can see for melody, we try to derive melodic descriptions like segmentation, similarity, and motif discovery. And in rhythm also, we try to extract meter patterns and high-level structure. The common pattern here is we start with a continuous signal and try to rediscover discrete, structured information behind it. So this is exactly where the things have become difficult for ragas, because signal itself is highly expressive and it has ornamentation and variation, as previously said. So instead of always extracting structure from audio, the question I started asking was, what if we start with structure directly, like the symbolic notation directly? Let's think about it. How do musicians actually learn and work with ragas? They, of course, follow the oral tradition of Guru Shishya Parampara, but along with that, we also use notation for teaching, for composition, and for archival. Now, because notation we can see that it is written in text format. So can we treat notation like language? If yes, for an audio developer, this is a powerful idea because it lets us reuse an entire ecosystem of NLP tools. That means we can apply NLP to music, notes becomes tokens, phrases become n-grams, and ragas become documents. But for an accurate analysis, we need accurate data in large quantities. So here comes our paper where we built a data set of over 2,200 notations from 7 sources covering 337 ragas across Hindustani and Carnatic traditions. And this required a lot of cleaning and normalization by experts. And it also enabled large-scale symbolic analysis for us. So once you have a good symbolic data like this, a lot of things become straightforward. For example, generation. You can build a composer using n-gram models, and because you're working with discrete sequences, like individual notes, sa, re, ga, ma, so local dependencies will be modeled, and I'll play an example generated in Raga Shivranjani. So both the rhythm and melody part is coming from the n-gram model, which is trained on some composition in Raga Shivranjani, and everything is just notation. So we can also experiment with harmony by combining scale constraints and rhythmic structure. For example, if we have Raga Asavari and we want to create chords for it, then we can use the possible notes in that scale. And the tala basis, we can use different vibhags. The starting point of vibhag we can use as a chord strum. And I would like to show you this example. What happened here was just the notation was given, the right hand part, and the tala markers were given where each beat lies, and the algorithm played chords by itself. But this is exploratory, so it shows that you can have additional musical concepts based on top of a basic structure that you make of notation. And now let's quickly run over some tools which you can use, not necessarily NLP. So this is the idea of TPMs, where you create a transition probability matrix of which note is going to where. So if you have Sarega, Sa to Re is a transition, Re to Ga is a transition. So you compare that for different ragas. So for Desh and Bhupali, you see it's different. For Deshkar and Bhupali, you see it is similar because Deshkar and Bhupali are similar ragas. So you try to calculate distances based on it, like KL divergence or some other metrics. And then another way is to use TF-IDF. This is an idea from NLP where each term and document, you can find the importance of a term within a document. So basically, for a raga, you have a sequence of notes, and for each sequence of notes, you create the different words, which are like n-grams, and then try to give importance to the words compared to all other ragas. So distinctly unique phrases in a raga like show up with high value. And using those numerical representations for a raga, you can try to plot it on a big graph, because we have like 337 ragas, we can just plot. And what we saw was interesting, like similar ragas are clustered together and different ragas are far away. So that is one observation we saw. And also similar ragas across traditions, like Yaman and Kalyani, Hindustani and Carnatic, are like very close, if you can see here. And yeah, basically that was my presentation. So next step from here, what we can do is do better audio and symbolic combined pipelines and better modeling of ornamentation like gamakas, and better control systems like MIDI polyphonic expressions, so that each channel will hold a single note and all notes can have different expressions of their own. So that is more suitable for Indian classical music. And the conclusion is that audio is expressive and ambiguous, but symbolic music is also like useful because it's structured, learnable, and even though if it is incomplete, we can have some high-level analysis on top of it. So best systems would combine both approaches. And yeah, thank you. That was my talk today.
It was an amazing talk. Let's keep the live stream active because we have time for some question and answers. So any questions that anyone would like to ask Soham about this?
How's TF-IDF help in our data visualization here?
So we used TF-IDF to generate Raga vectors. And the Raga vector is basically a row in that TF-IDF matrix where each column is a phrase. So we define a phrase as an n-gram. So it can be like Sarega, Regama, all possibilities. It is like in thousands of numbers. So TF-IDF is an equation that uses term frequency and inverse document frequency. So basically it tells you how frequent a phrase is in a raga and how frequent that phrase is in all other ragas. So if that phrase is common to all ragas, then it's not important. And if that phrase is only unique to a raga, that is important because that is a characteristic of a raga. So that way, we get a vector of all phrases' importances.
It's a kind of outliers, right?
Outliers you will get if you have like rare ragas maybe, but this works for all ragas.
Okay.
I didn't get the outlier part.
Okay, that's fine.
Hello. Yeah, it's great, Sogam. It's a nice presentation on Carnatic music. So I like to have one question over here. So you have extracted the n-grams, the diagrams and trigrams from the music, I think. Yeah?
Yes.
So have you tried for extracting the motives out of that?
Yes. So by motifs, you mean phrases, right?
Yes, that's what the Swara Sancharas, which I talk about the motives specific to
Yes.
the Carnatic music.
Yes.
But yeah.
I have extracted them, but those are in a notation format. So the gamaka part, it doesn't carry.
Okay, okay.
So, for example, I don't know Carnatic examples but I know Hindustani examples. For example, Yemen will have Nireg and Dhanisa, Madanisa, all these puckered kind of phrases as top importance values in the TF-IDF.
Okay. So, but the motive, the main part is the gamakas. So, but we can't extract it directly out of the notation. Yeah.
Yes.
Okay. But they give the high identity towards that. Yeah. Okay. You are trying for that extraction.
Yes, we are trying to kind of add gamakas to notation, but not the reverse way as you are saying.
Okay. Okay. Thank you.
Thank you.
Any other? Oh,
So why look at specifically like a discrete protocol like MIDI? Why not something else that is more continuous?
For which task exactly?
To sending it to your synthesizer, sending your notation to your synthesizer.
Yeah, that's a good question, and that we are actually trying out now because we are looking into DDSP and other things that generate continuous things. So this was mainly for analysis of what notation we had, because what notation we had was a huge corpus we got from all different websites, and we wanted to use the discrete notations and do some analysis first and then add gamakas later.
But like for something like OSC, which is still a standard protocol and works pretty much everywhere now.
Yeah, but how do we know what gamaka to put on what node, and how will we learn
No,
that?
just as a transfer protocol, like just as a data transfer protocol, that's all.
Okay, yeah, but first we need to know the curves, right? That's the main problem. Yeah, thank you.
okay, we have time for one more question. Oh, there.
Hey Soham, thanks for your talk. You demonstrated how you'd approach Bhupali and Deshkar, and as well as you demonstrated how you would approach the ragas which have ascending and descending are different, like this. What about the ragas which have both of the notes, like Jai Jayanti has both Ni, both Ga? How do you approach analyzing those?
So you're talking about that TPM?
Yeah.
So it has all 12 notes separately, so it doesn't consider both knees as one. So each different note is on its own row and column, so that's not a problem. And even we can extend this to like makams and all, which have like 24 or so notes. And we have done that, and we have plotted makams along with ragas as well, but obviously they don't cluster together.
Thank you.
Thank you.
All right, so let's give a round of applause to Soham for an amazing talk. Please, Soham is still here throughout the event and also at the after event meetup. So if you have questions later on, feel free to meet him and discuss these ideas, and maybe we can come up with some solutions for what even Abhinay asked about continuous signals and all that. All right, so we'll be starting the next talk shortly. And All right, how's the energy now? Okay, so we have really good set of talks today. So let's go for the second one. The second talk is by Aman Jagwani, who is an audio programmer, musician, and researcher from Mumbai, specializing in embedded audio research and open source musical programming and signal processing system. Aman will be giving a talk titled Embedded Musical Signal Processing with Csound 7, from microcontrollers to FPGAs. Please give a round of applause for Aman.
Thank you. Thank you. Hello, everyone. Very happy to be here. Very happy to meet everyone and learn from everyone, and looking forward to all the amazing talks today. Thank you for having me. So my name is Aman Jagwani. I'm a PhD researcher at Maynooth University in Ireland. I'm working with my supervisor, Victor Lazzarini. My work is focused around embedded audio, embedded signal processing, interactive systems, musical, DSP, and things like that. But I also have a background in improvisational music, modular synths, so everything kind of combines into my work. So today I'm going to be talking about Csound. Csound is an open source, free and open source sound and music computing system. It's a higher level music programming language. So similar to if you use Pure Data, Faust, Super Collider, and languages like that, Csound is along the same lines. You can do the similar things with Csound. It has a very rich legacy. It's based on the Music N languages by Max Matthews, which was developed in around the 1960s, and then it was ported to C in the 80s, and then from there it's evolved till today. And it has a good balance between music programming legacy and modern features. Victor Lazzarini is one of the main developers of Csound, and I'm also part of the developer team in the embedded systems and embedded audio, and specifically bare metal embedded audio area. So our talk is going to focus on that today. So we're going to talk about using Csound in a musical context within bare metal and embedded environments, and we'll show some platforms like microcontrollers and FPGAs as well. So a little bit of background. As I said, Csound was a C port of Music 11 by Max Matthews. Then it evolved through time. It worked on transputer hardware, DSPs. Then the library plus an API was introduced in Csound version 4. The library became fully re-entrant in version 5. Then it was part of the One Laptop Per Child project. It works on supercomputers. It works on iOS, Android, web, even GPUs. There's a lot of work on parallel processing with GPUs with Csound as well. And then in terms of embedded programming, the first versions were with embedded Linux systems like the Galileo and Edison system, and then Raspberry Pi. Following that, the Bella, which is a low latency embedded Linux audio board, also introduced, the Csound support was introduced for that as well. And then now, recently last year, the version 7 of Csound was introduced, in which we added bare metal support as well. So bare metal means no operating system, chips or microcontrollers, and Csound supports that as well now. So a little bit about how programming is done with Csound. It is a higher level domain specific language. So you mostly work with unit generators called opcodes. So they're like modules. They're in the form of oscillators, filter, reverb module, things like that. And there's a vast library. Pretty much anything you want to do with synthesis or DSP, you can do. Spectral processing, granular processing, all of it. You can also do DSP coding from first principles, so you can also make your granular processor or delay lines from scratch within Csound. So multiple levels of interaction. And then you can also extend Csound yourself by adding plug-in opcodes. So you can make, with C++, you can make your own opcode or module or unit generator, which you can use in the Csound language. And then it integrates across platforms such as the web, embedded, Unity for games, iOS, Android, all of it. And you can do the integration through the Csound module API. And then there are multiple front ends for Csound programming. There's Csound Qt, there's the web IDE, and there's a front end called Cabbage, with which you can make VST and audio unit plugins as well. It's by Rory Walsh, Cabbage IDE. So this is a quick example of how you do programming for Csound. So first, there are just some options set on the top. 0 dBFS equal to 1, number of channels. The K-SAMS basically is the control period. In audio programming, we know there's a distinction between audio rate and control rate. So this basically defines your control rate. And then you program instruments. And then within the instruments, you basically link modules across each other. So we have a VCO2, which is a oscillator there. It's like a virtual analog kind of oscillator, going through a Moog ladder filter, going through a reverb. The syntax you can look at more on the Csound website, but basically it's just modular linking of unit generators in the Csound programming. So if you want to start working with Csound right now, you can look at the Csound manual and tutorials on the website. The main Csound repository has build instructions and other information. And then the web IDE is probably the easiest place to start. You can start on your phone or your iPad or laptop and start working with Csound there. And you can look at Cabbage for plugin development. It's free and open source, so you can start easily anytime. These are some examples of plugins that ship with Cabbage. They're all free. There are about 200 plugins that come with Cabbage, and then you can make your own as well. So now going into bare metal. So bare metal means it's an embedded system or chip or a microcontroller with no operating system. There are certain limitations sometimes in the processor. Might be a limit in the computational power of the processor. Floating point unit may or may not be present. You may have to work with fixed point. And then memory is quite limited, both for the flash storage for storing your program as well as RAM for access from the program. And then it has good integrations with hardware like sensors and MIDI and those things, so you can connect your sensors very easily to microcontrollers, for example. And then the programming now, generally C and C++ tool chains are available for different kind of bare metal platforms. And in terms of debugging, generalized debugging tools may not work, but usually you use vendor-specified debugging tools, whatever you get with the particular chip. And then some examples are STM32, ESP32, Raspberry Pi, Pico. These are all bare metal platforms. So porting Csound to bare metal required a few changes to the original Csound library and original Csound build system. One thing was there could be no dynamic loading of opcodes. It had to be changed to static linking, but this has been done in the Csound system since 2010, so that was okay. Csound had a lib sound file library dependency for very long, so that required an operating system. But in Csound 7, we removed the dependency, and we can now implement a custom sound file backend, like for example on a microcontroller, keep the sound files on an SD card, and you can still build Csound. Earlier, it required the operating system mainly for this dependency. And then, as we said, memory might be limited, and especially for the heap or the dynamic allocations that Csound does, mostly in the initialization period of Csound. So we made a custom malloc, like a custom allocator for Csound to be able to allocate to external memory in a microcontroller system. So for example, if you have a development board, you often get extra RAM that will be external to the actual chip. So we map the heap over there. It's a bit slower, but it's mainly for the initialization part. So during performance and audio runtime, it's not too much of an issue. So things like networking, threading, and other things that are not possible on particular bare metal systems are removed. So that's how we are able to run on the bare metal system. So the first platform supported for bare metal with Csound is the DAISY. So the DAISY is Electrosmith's digital audio programming and embedded computing platform. It's based around the STM32 microcontroller. It has an ARM Cortex M7 CPU, and it has onboard audio input and output, as well as MIDI, USB, and UART interfaces all on the board. The flash storage is limited on the chip, which is 128 KB. So the firmware had to be placed on an external 8 MB QSPI flash, which is there on the DAISY. And then there's also only 1 MB of internal RAM or memory for that the microcontroller on the DAISY can access. So the board has external SDRAM up to 64 MB. That's where we put the heap and use the custom allocator to allocate there. And then when you program for the DAISY, the firmware that you make is basically a combination of the Csound API as well as libDAISY, which is Electrosmith's hardware library. And then Csound is compiled as a static library for the STM32 for basically the Cortex M7 hardware, and it can be ported to other platforms with the same architecture as well. And the program, the firmware that you will use, it embeds a Csound program, which is usually called CSD or Csound document. It embeds it as a string, and that whatever you put in the Csound file runs in the audio callback supplied by libDAISY. So the point of embedded systems often to connect with the rest of the world through sensors, through MIDI and other interfaces. So we had to make an interface for Csound on the DAISY with sensors and other peripherals. So this was inspired by the implementation for the DAISY, for the Bella version of Csound. So analog ins, where you basically would connect your potentiometers or sensors, they are connected through Csound software bus channels. So you basically, if you want to read from a sensor, you connect your sensor to analog 1 on the DAISY, and then you can read it with this line. Like you use the chan get opcode. This is the which is there in Csound, and you just put the name of the channel. So that's how you can read sensor information within Csound. The digital ins, ones and zeros switches, basically are connected to Csound with a custom opcode. We called it digi-in DAISY. Basically, you'll get switch kind of information to that within Csound. And MIDI is connected over USB or the UART interface on the board. And we have a custom MIDI backend module to connect the DAISY's MIDI implementation with the Csound MIDI callback. And the logging and prints and debugging from Csound is also connected to the DAISY's serial logging. So basically the goal is you just have interaction with Csound, and you can make DAISY firmware and DAISY applications, put that into pedals, synthesizers, whatever audio tools you want to make yourself. So this is a demo of a polyphonic virtual analog kind of synth made with the DAISY. This is the DAISY on a DAISY pod, which is a prototyping board supplied by Electrosmith. So 8-voice polyphony with reverb as well. Yeah, that's just a simple demo. So the next platform I'm going to talk about is a more generic prototyping board. DAISY is more audio specific. Now this is more generic, where you would want to make your programs and test how they connect with peripherals, how you can do networking, for example, how you can do display in conjunction with audio programming. So this is the STM328747 discovery board. It looks like this. It has a screen as well. So it's just a little bit more expansion into prototyping rather than making audio specific products as well. So these are the specifications of the board. The main thing is the Cortex M7 architecture is the same as the DAISY, so it was very easy to port to this. But this is also dual core. It has Ethernet connection. It has display. So it's basically lets you expand the connection of Csound with peripherals more. So in this then update was we made a more native audio backend. So in this Csound writes directly to DMA buffers. In the DAISY handled the audio input and output. So we just copied from their buffer into the Csound input and output buffer, and the opposite of that. Here we write directly to the hardware through Csound, so it's a bit more low level connected. And then all the peripherals that I mentioned are integrated. And we also use the dual core architecture in this. We put, for example, networking. We have a Csound as a UDP server, so you can at runtime give it commands and do live coding with it as well. So we put that on the Cortex M4, and we did the screen rendering also on that, and we did the audio processing on the M7, and then we use a circular buffer to just to communicate between the two. So this is a demo. In this demo, basically, I'm sending UDP messages with the UDP protocol from my computer to the board, and that is playing the notes with Csound, and you can see it also on the screen with the Csound messages. Basically that's what prints from Csound through the logging. So this can be useful in things like installations where you want to remotely control your audio system, or even network performance, live coding, all of that. And then now the last platform I'm going to talk about is a co-processing platform, which is with the FPGA. So FPGAs or field programmable gate arrays are they're integrated circuits or chips with programmable or configurable logical units. So basically you program hardware with FPGAs instead of programming softwares. I did a talk a couple years ago at ADC India. You can get more information on FPGAs from that and as well. So it's usually FPGAs are packaged as a system on chip with a ARM CPU or like a CPU with the programmable logic, which is the FPGA part, and they both work together in conjunction. And FPGAs allow a lot of parallelism. They allow low latency, sample by sample audio processing. So they're quite useful for audio processing tasks. They're used in a bunch of synths and interfaces as well, especially for multi-channel and low latency applications. So they are a bit difficult to program, but there are these HLS tools, which is high-level synthesis that lets you program them with C or C++ and convert it into FPGA hardware as well. So the way we implemented it for Csound is we run Csound on the CPU, the ARM CPU of the chip. So we use the Xilinx Zinc 7000 on a Zybo Z720 board for experimentation. This has a ARM Cortex A9 CPU, so Csound runs on that. And custom versions of Csound opcodes run on the programmable logic or the FPGA part. And then we do co-processing between both of them. And we've implemented the communication system to send audio from the CPU to the FPGA and back. So all that is all taken care of. And also sensors and MIDI and all of that is all implemented. This is there in the Csound repository as well. You can have more of a look there. But basically you leverage the processing powers, low latency, parallel processing capabilities of the FPGA along with Csound. And what runs on the FPGAs are ports of Csound opcodes. So we already ported Reverb SC, which is Sean Costello's original feedback delay network algorithm in Csound. It's part of Csound. We've done granular synthesis, and now we just did time-varying convolution also. So all of this can be explored on FPGAs, and they leverage the powers of the FPGAs as well. So some examples of using this would be, you would make, Csound has very capable generative and stochastic capabilities. So you can make generative systems on Csound that are controlling sound synthesis and processing on the FPGA, or you can do sound synthesis, generative synthesis on Csound, and then do complex processing on the FPGA. So also good for installations, good for synths, processing, everything. This is a quick demo of a generative system made with this. The reverb processing is on the FPGA, and the synth part is on the CPU. And also the generative, like the algorithmic scheduling of notes and modulations all on the CPU. And that's the Zybo Z720 board that we use for experimentation. So just to conclude, with the emergence of Csound 7, Csound is able to target almost all kinds of computing platforms. It's present widely in different applications and plugins around everywhere in the world. Bare metal computing opens up opportunities for maker projects as well, and using Csound provides an easy entrance into kind of a technical bare metal programming environment as well. And then co-processing, we are just beginning with that. It's a great active area of research, and now it can be done, Csound can be used for this research as well. Yeah, and FPGAs, there's lots more to harness there as well. That's it. Thank you.
That's an amazing talk. We have time for questions, so let's hear from the audience. Can we give a mic there?
Hey, it's so happy to hear that Csound is on Daisy now. So how do we do this? It's on the main libdaisy.
Yeah, no, it's actually in the Csound repo now. We are trying to get it integrated more with Electrosmith. So what you can do is you can go to the main Csound repository, the develop branch. There's a Daisy folder. So there are examples, build instructions, everything there. It should be pretty straightforward to get started from there.
Any specific dependencies that should?
It's all taken care of. We're using basically Electrosmith's dependency, and you have to just build bare metal Csound yourself.
Okay, so just GCC, Clang.
Yeah. It will be, you'll need the ARM embedded toolchain,
Of course,
which is
yeah.
there with DAISY anyway. So
Yeah.
it will already, if you have the DAISY C++ environment in your
So hopefully
computer,
we'll
all good.
at some point have a upload to a DAISY button
Yeah,
on
that's the
Csound.
goal. That's the goal.
Wow.
Yeah.
So excited.
Thank you. It's also planning to integrate with Cabbage, which is the Csound IDE. So just export from there to DAISY. Rory Walsh is trying to do that as well.
I think we had another question there.
Yeah, hi. So coming to the porting, right? So with respect to DSP library, so how about supporting other processor?
Other processors?
Yes, suppose if I'm developing for ARM, right? Suppose for if I want to port it for other processors, so will it give out optimized code?
So right now we've implemented for ARM only. We will explore other processors, but then we'll have to work with their tool chains and do the cross compilation for the other processors. Right now, this stage, ARM-based architecture is supported.
Thank you.
The discovery board is essentially what the DAISY is on, right? Because the same codec on it, the same the Cortex processor on it.
The processor is the same, is the STM32H7. The
Yeah.
codec is different. Because DAISY also changed their codec over time. So
I have the older one, which is the same. as
yeah,
the
so that
discovery
might be,
board.
yeah, that's the Cirrus Logic one, which is on the discovery board, and that will be on the older DAISYs, I guess.
Got it. Nice.
Okay, we have one question here.
Hi, so my question is because I'm interested in compilers and Csound is a compiled language, right? So any specific optimizer passes that you have that are not in regular languages like C, C++, but they are in this audio language?
So basically Csound is made with C and C++ only, so the optimizations for Csound will be passed on from the optimizations available in C and C++. But there are things like prioritizing the audio processing. In desktop environments, the audio thread is the highest priority. For us, your audio runs in the interrupt routine, which is the most high priority. So basically, it would be optimizations from C or C++ because Csound is basically a wrapper around C.
And what about bare metal? Like, do you handle your own scheduler for that?
No, so bare medulla doesn't have OS or scheduler. So basically, just runs your firmware, your simple program. So we have taken Csound here to work without the scheduler like that.
Got it, thanks.
Okay, we have time for one more question.
Hey, hi, nice presentation. I have one question. I think you already covered part of that it is only done for the ARM, right? So how difficult it will be or how we can port it on different platform like the custom DSP platform or like MIPS or no?
It won't be different at all. It's just the matter of using the tools for that.
Just the compilers, right?
Yeah, just the compilers.
And it won't be optimized for those platforms. That's where we need to see whether.
Yeah. Basically, the static library version of Csound you can put on any platform. You have to just use their tools.
Right. And another thing, it's a bare metal. Have you tried on FreeRTOS or this kind of?
FreeRTOS not tried yet. That's one of the next steps. Embedded Linux is well supported.
Right. Okay. The reason I'm asking because when we are going to custom DSP, we may go with the bare metal, we go with the FreeRTOS or this kind of software architecture, right? So.
Yeah, so it should be straightforward to go to FreeRTOS. The reason we went with bare metal first was because there is a platform like DAISY that is for musicians and hobbyists as well. So it's a easier entry point. Then later we'll expand. Like so, from DAISY we went to the prototyping and FPGA. Those are a little more complex. So the point of bare metal first was to get to a platform like the DAISY.
Okay. Thanks.
Thank you.
All right, so that's all we have time for now, sorry. So please feel free to meet Aman later on in the conference and at the after-event meetup and ask your questions and discuss more ideas. It's so interesting how we went from Indian classical music to low-level programming in just like one talk switch. So again, a big round of applause to Aman.
Thank you.
and also our getting to next talk. So far we have heard talks about Indian classical music. We have heard talk about low-level programming. And now let's have a little bit of change of topic. So our next presenters are Kratika Jain and Gowdham Prabhakar. Kratika is a music technology researcher and NIME developer at IIT Kanpur, working at the intersection of sound engineering, human-computer interaction, and expressive digital instruments. Gowdham, he delves into various topics such as human-computer interaction, robotics, extended reality, artificial intelligence, music technology, and many things. Gowdham also runs the Hive Lab at IIT Kanpur, which I hope he'll be talking about in this presentation as well. So their talk is going to be about human-computer interaction practices and musical interface design. Let's give a round of applause to Kratika Jain and Gowdham.
Thank you, guys. Thank you, Prashant. So, hello, everyone. First of all, I'd like to a huge thanks for Prashant for arranging all the things. So, let's start quickly. It will be most of you guys would have actually already heard of what is human-computer interaction, but on the perspective of musical interfaces, music technology will actually show some light. So you know the instrument, it's piano, right? So how do we actually play with it? What kind of actions would you actually just show? Playing piano this way? Okay, yeah. So using our motor skills, hand motor, we do this gesture with fine motor skills of dexterity of fingers movements. This is the way we interact with this particular instrument to generate sound or produce sound. And there is an engagement that's getting connected to us, and then something moves on. So likewise, these instruments, so guitar, we do this kind of, and there is also this particular technique of actually handling or using this or interacting with this instrument, particular instrument, is also comes with the physical constraint of the instrument itself. The physics with which the instrument is playing the sound, and how we actually plug chords from the string, because it's a string instrument, and the shape of the instrument itself, it actually feels like we'll have to hold it this way. We can also try different ways as well. So, and let's say tabla, it's always most of the tabla players, they sit on the floor and then they actually play the instrument. And this instrument, some of you would have actually known, it's theremin. It's kind of playing music in air with some hand gestures. Using radio waves, it actually detects and then maps it to sounds. And this is violin with a bow. It's a separate device piece with which we actually, instead of plucking the string, we actually sweep on the string. So these are different ways by which we interact with specific instruments, and this interaction actually started evolving since a long time. And so when we actually talk about the interaction, basically it's the musical instruments is not just about making sound, but also we actually see in the perspective of how the interaction as the interface is actually happening between the instrument and the human player. So so that's how the human-computer interaction actually plays a key role in designing a musical instrument. So, and some of the key concepts we actually apply for designing our instruments are affordances, signifiers, mapping, feedback, and mental model. So we might not be having much time to actually dive into these topics. So these are some of the concepts that we adapted from interaction design principles. So affordances is basically the way in which how the user and the instrument or a device is interacting with each other. What are the different ways I can actually do something with it, or I can make an action something with it. Let's say this is a microphone, and then it feels like, I can actually hold like this. So that's actually happening because of the affordance that this particular, rod actually gives me. So, or sometimes I also feel that it's actually wobbly, and then I can also do these kind of stuff. So it also gives me these affordances. So likewise, when we explore what are the affordances an instrument can actually give, people try leveraging all different possible actions, and then they expand the degree of expressions that from one instrument a player can actually leverage. So likewise, we try to ideate on different ways of interacting with an instrument, or sometimes even converge on to designing a new instrument itself from scratch. Let's actually quickly go through the works that we have done so far. Now Kratika will actually
So in this, did you guys notice anything that happened right now in the music? So in this, what happened? Using eye gaze, I just changed the tone of the instrument. So in the beginning, when I was playing this, now from eyes, I'll change the plugin. So we designed this system because whenever you guys are musician, you play keyboards and you play a lot of instruments, and meanwhile you have to change the tones. But sometimes what happens, the music becomes so complex that you don't even get time to change, and you have to practice every time. So we give one assistive thing that you can actually change the tone using your eyes while playing. So this is one thing that we call it like eye gaze tracking and changing the plugins while playing the instruments. So in that, I was playing Riders on the Storm by Doors, and then I was switching with the organ and piano while playing it. So one more time, I'll also do it. Next, this instrument is Swarings. This instrument has started as a coursework project where we actually have to design a new kind of interaction, like new instrument based on instrument. If you guys know about NIME, like new interfaces for musical expression, we started with that, and the idea was actually to have new sort of interaction while making the instrument. So the idea, the inspiration come from the accelerator from a bike or rings. That's why you see a lot of rings here. And when beginning, like when we started, then there is also a small musical problem in MIDI keyboards. Not problem, but the thing that you can't do it in MIDI keyboards, that is, you can't control pitch bend, modulation, and the note like simultaneously. So in this, what happens? This ring has this kind of interaction where this movement is pitch bend and this movement is modulation. You can control the note individually, but also if you wanted to do both of them together, so you have this diagonal movement, you have this circular movement using the rings. These all rings are like 12 notes, basically 13, one octave note, and this is a copper tip that when you touches it, then it controls. So I'll play a short clip of it. is we also give pedals in order to change the octave. What happens whenever you're playing a piano or guitar, whenever you're shifting to the lower frequencies to the higher frequencies, there is a small time that you always take to actually switch from lower frequencies to higher. But we are giving this pedal so that you can quickly change it in a second right now. So this Swarings, it started in January 2025, and this is 8th iteration, and we are still iterating it. And it also got published in UIST 2025. Next is, so in Indian classical music, we count tals on this da, din, da, like on the palms. But there are more different, like in Karnataka, you do it like on lap, and in Hindustan, you do it also like this. But one of the form is you do it like this when practicing. This started as a problem when for Indian classical singers, when they're practicing music, they have to be on rhythm, they have to be on tal, and they have to find accompanist every time, or either they use metronome. But the old way of, the way they count is like this on the palm. So we give a feedback using a glove, where whenever they are practicing singing, they'll hear a tabla bowl, whatever the tal they are practicing in. Not the complex, it can't do complex, but they can be on beat right now. So there's a small clip of it.
Then, da, ha, then, da, ha, then, da, then, da, ha, then, da.
This is Swarings and this tabla glove are both MIDI device. Tabla glove is wireless, and it can be connected to any DAW, both of the instruments. And next is this project has a lot of POVs, like different. When we started, we just thought it's we actually tried something Gravity Well. Do you guys know Gravity Well? Okay, so Gravity Well is like just simple concept where center mass in the middle, and when you project the planets, that moves around the center mass. And when the if the mass is
basically, sorry, I will take it. So gravity well is a way with which physicists, they actually illustrate or demonstrate how gravity works in Einstein's way of actually, relativity. So basically, gravity, it's not a push or pull force, but rather it's a motion change due to the curvature present in the space-time continuum. That is his proposal. So gravity is not a force, but rather it's an effect of a defect that actually is done by the mass that is being present in the space-time. So for that to illustrate, they actually put a fabric, a cloth, and then they actually place a huge mass at the center, thinking that that's the star, that's a center of, let's say, sun. And then when we actually throw a few balls of different masses around it, it tries to actually, because of the curvature, it tries to actually spin towards the center. But here there is gravity also is involved already. Newton's way of explaining also can be done, but to illustrate the quantum level of how the gravity is working, we generally physicists, they actually illustrate on. Using this, she actually proposed an idea of, can we actually sonify the movement of the balls.
So the sound, we'll check the video and we'll actually explain each of the things once. This one was the Nebula preset. One thing is, this is the well. We placed a camera in top of it, and we were getting all the data like x coordinates of the well, y coordinates, angle from center and all the data, and we were actually processing into the max. First, we run a Python script using OpenCV, and then send the data to the max using OSC, and then sonify the data based on some small concept. Like nebula is a star that expands in x-axis, so we put it like reverb. Similarly, y-axis is something, angle is something. Like that, we actually did the sonification of this. And next, come to the next preset. So in this, we started with a wave. We can select any wave, saw, sine, and then based on the ball's location on the well, wherever we are projecting, it will actually sonify the data. That's how. And last one is interesting. That So in this, there's a, like Kepler has already set some laws related to universe and music. So one of the law was when the mass is near to the center mass, like the planet is near to the center mass, it will sound higher in pitch, and if you're going relatively lower, like back, then it will sound lower in pitch. So we use this law, like if the ball is near to the center mass, it will sound higher and then relatively lower. And then after that, we used different sorts of scales in this, like we used Indian classical ragas, like ascending, descending, because they have sometimes different, like ragdes. And we also use major scales. Fun fact is, with C harmonic minor, we tried to play it, Harry Potter themed song, something it was coming okay, like a background of BG. And like that. It was not intention to actually make it, but just to experiment how it will come out and how the sonifications can work out with gravity well. And one more thing, when you're talking about interaction, most of the instrument you see, you have interaction like full control or half control on it. But in this well, like you see, half control is with the user. I can project the ball anywhere, and it will obviously produce different sound whenever I'm projecting. It's not algorithm, it's based on location and wherever we are projecting the ball into the sphere, like gravity well. Next is hand.
And also a shout out to our team members, and one of our close coordinators, Alvin, is also here. So he was also part of Gravitone project. So we actually demonstrated. Kratika went to Canberra last year to present this work.
And this is last, like how using the hand motion. You guys know about Rolly's airwave, right? Similar kind of thing we did using leap motion, mapping the hand gestures to modulation and all. This is our team Hive, like we do everything. This is like Gowdham sir can tell more.
Yeah, so Hive stands for Harmony Interaction Versatile Exploration Lab. which we started by 2023 beginning at Department of Design IIT Kanpur. So a shout out to our guys. So some of the people here you can see are closely associated with music technology. We also started music tech hardly maybe 1.5 years ago.
Yeah,
Yeah, so that's who we are. And we also, where is the, so you can actually check out our handles. You can please follow us. And just to get to the academics part of it, we also introduced a course on sound design and music technology from this year onwards. So there is a course that's going on right now. So in India also we have started now. So hoping, and we are closely collaborating with Prashant, Alvin, and many of us here. So they're also giving guest lectures and training our students. So, and yeah, thank you guys.
It was an amazing talk. I have actually had the honor to actually visit the Hive Lab and try those gloves things and the other instruments. And it feels surreal because often we think about musical instruments in terms of fixed set of notes, even if it's like Indian instruments like harmonium. And it actually changes your way of thinking as an artist the moment you have different modes of communicating with something, right? So let's take some questions. We have some time for questions. So.
Hi, thanks for the good presentation. So like I have wondering, like you have showed some hand gesturing controller, right?
Yeah.
So as per our DSP processing, we know how much time it will take to identify the gesture. How you guys are handling to it is kind of latency kind, like the note has to change immediately. Like how it is handled.
Yeah, basically the tracker that we used is a commercially off-the-shelf tracker. So it's called Leap Motion, that actually detects hand gesture in real time as quick as possible. Long back, we used to use it for hand tracking for virtual reality headsets, the XR headsets. But now even in XR headsets, the latest ones, MetaQuest 3, which is the cheapest, I would say, it's around 50K. Even they have the camera system to actually detect your hand tracking as seamless as possible with almost insignificant latency. So using image processing, the tracker that we use is infrared based camera system. For latency and other things only they use that. But even now with stereoscopic camera, computer vision, people have come up with good, even with media pipe also you can actually significantly, you can have almost no latency, perceivable latency.
Yeah. Thank you.
All right, any other questions?
Hi, awesome presentation. Thank you. I was fascinated by swarings. How did you synthesize the Indian classical music? Like, was it like a record a true note and then put a filter on it, or like synthesize it on computer? How?
We haven't synthesized it, so it's a MIDI controller only basically.
Okay, sure.
So the plugin that we used is, I forgot, Logic Pro?
No, it's cinematic suspense, but we have used a lot of plugins that can show the expressions of swarings, because when you talk about swarings, it has new expressions that mostly you can't find in many instruments, like using modulation and pitch bend together. So we have to select certain plugins only. So one of those plugins we used is Cinematic Suspense in Logic Pro, and we are using MPE protocol in this.
Sure. Yeah. Thank you.
Thank you.
Hello. Sorry, I had a question.
Yeah, hi.
Amazing presentation. Had a quick thing about the gravity well. So I noticed that there was a sitar type of sound at one point. So I was curious what sensors or how you're going about producing the actual instrument sound there.
So actually in Gravity Well we used two kinds of direction. One was based off frequency based, another was plug-in. So the frequency one was the first two where you were hearing nebula and wave preset, some uneasy kind of sound maybe, or maybe I'll say 9 kind of sound only. And talking about that one, we were using a plugin Logic Pro only, but our main focus to actually focus on how the sound can come out, how the music can come out through the gravity well. So we used 2 pathways and we haven't synthesized anything yet. Instead of using this nebula and this wave preset.
Right. I think I just add that whenever like people are starting out experimenting with these new formats, initially the output will sound like noise. Like, I mean, noise is also a very subjective like term, but it often will sound like, okay, this is very haunting like, which is what happens when you use the frequency mapping. And this is where I think there is a scope of collaboration between artists and developers, because developers might be only mapping frequency, but then the artist can come and help them, okay, you know what, can we just quantize this to these frequency values, and we'll get more Indian classical, for example, and Carnatic and all that versions, right? So the reason I'm saying this is because a break is about to come, and the audience has a mix of artists and developers and people who have actually been working at the intersection of both, right? So please make use of the time during the break. And let's give a round of applause to Kratika and Gowdham.
Thank you.
All right, so we can have the live stream to be on mute, but He'll be giving a talk on from DAW users to audio developers, teaching JUCE to creative minds. Please give a round of applause for Milap.
Good morning, everyone. It feels really good to be here. First of all, thank you, Prashant, and the whole ADCx team for having me here. So, why I call my presentation from DAW users to audio developers is because most people, most music producers, most sound engineers, live sound engineers, usually end up using equipments, plugins, all of those components as black boxes. You know what that black box is doing, you get some output out of it. What sometimes that approach prevents is you not having the understanding, the full potential or understanding of how that black box can actually be used to its full potential. How you can probably, if you understand the algorithm inside the black box, you can probably tweak it a little bit to your liking, or you can add different kinds of modeling into the algorithm to make it to your liking, which is where what I'm talking about could come in, essentially. So to introduce myself, I'm Milap Rane. I started off as an electronics and telecommunications engineering student and got my degree in it. And while I was at it, I discovered signal processing through music production. So I was also simultaneously working freelance as a music producer, and I saw a similarity in what was being taught to me in class and what was happening when I was actually producing things. Filters was kind of my gateway into signal processing, and I fell in love with it essentially. Then I completed my master's from Georgia Tech in music technology, and I'm currently a PhD candidate at University of Surrey, and I'm a performing Hindustani classical musician as well. So why I'm talking about this is because I have somewhat of a background in music technology, and having recently shifted into education, I thought that some kind of a background is important, and how I have tried to use my background to be able to get onto this new journey that I've started. So I've always had somewhat of an interest in software engineering, and particularly bootstrapping, in the sense that you take a new technology, learn it from scratch, and bootstrap your way, try to make it as simple as possible, and so on. Why is teaching JUCE or any technology to a creative important? Once a creative has a better understanding of how the technology works, how the algorithms work, the technology will be used much better. I mean, if you understand that you can tweak a compressor to give it a little bit more of a high frequency sound, which might be something you might want to use when you are an electronic musician, that could essentially mean that you create your own plugin, create your own workflows to work around it. And that will lead to more diversity in the music that you'll end up getting. And again, that leads to building newer workflows and your customized workflows for yourself. The other thing is algorithm design training will always help you improve problem-solving skills. There's enough research on this. And one personal example I can give is since the time I've actually started teaching these students about algorithm design, about the basics of coding, one thing that has happened is that they have had an improvement in similar fields like live sound, where in our curriculum we have something called a signal flow test, where the students are essentially made to debug as an exam. And the number of students that have done my course, and particularly this course, there was a marked significant increase in those students passing the signal flow test. Point being that they automatically learn how to do these basic things of problem solving, how to divide the problem into smaller parts, how to debug, how to understand what could be the exact reason you're facing a certain problem. And algorithmic teaching or teaching algorithm design usually helps people in understanding how they can think correctly as well. So that's a very important part of why I'm doing what I'm doing. There's also, industry also needs more ear-trained and creatively inclined technologists, right? All of us know how, for example, someone like a Richard Devine comes into play in terms of understanding how any technology can be used more innovatively, more deeply, and more thoughtfully. And in this way, we can build technologists who are users as well. And that is a very important direction that the industry is taking. And I felt like India as well could be at the forefront of that thought process. Of course, we have Richard Devine is an example I've cited already. We have Curtis Rhodes, who developed the whole technology of granular synthesis, if you can say so. Imogen Heap, who's done a lot of very good work on interactive musical instruments and so on. So, which is why I felt like documenting this process also becomes very important as well. So, how does my class look like? I have maintained anonymity here, but in general, here I'll try to explain what my class essentially looks like. So I have a cohort of 13 students right now. They come from all parts of India and roughly equally spread. There are 4 students in this cohort that have past coding experience at a collegiate or school level. They've worked with Python and JavaScript before. 5 students with absolutely no science background, mostly from an arts or a commerce background. There are 3 college dropouts or credit transfers, people who joined courses like engineering and science and felt like this was not what they wanted to do and came into the sound engineering, music technology side of things. So that also comes with past baggage regarding code, which is something that I have had to work with as well. And up to intermediate level of ear training and music production experience. So a lot of these students are already very good at music production and have very well trained ears. So they understand artifacts and those kind of effects or those kind of things in sound. So before I started the class or before I started this semester, the question I asked all of these 13 students was, when I say audio software engineering, what do you feel about it? Why I asked this question was because with software or with software engineering, there comes an inherent bias about it being technical or it being something to be feared about. This is something that even I had to go through because initially even I was not comfortable about it because coming from a classical music background, I am someone that lives in the moment and don't necessarily have high logical thinking skills. I'm better as an improviser and I'll kind of do something on the spot and manage things and go along. That is a markedly different approach from software engineering, where software engineering and coding is a very thoughtful skill. It's a very thoughtful thought process, right? People who taught me software engineering essentially told me that most of your work is done on paper even before you write your first line of code. If not on paper, at least in your head, right? So that is where I essentially wanted to take things. And once we asked this question, we got a certain number of responses. So this was qualitatively done, and I used NVivo to kind of generate a word cloud based on the responses. So here we will see that red, will lead you to words that might indicate negative feelings like fear, anxiety. Green are words that might indicate positive emotions, and blue are neutral or descriptive words about what they feel. You see the big red, confusing, difficult, overwhelming, intimidating, right? Then but there are some positives as well, which what to some people is confusing, to the same cohort of people it is also challenging. So that's already the right direction, right? You're confused with something, but you want to challenge yourself to learn it. That's a very good place to be at. And then you can see that there are a few positive words here and there, that they're curious, they are trying, they understand that software is a lot of problem solving, and that is where things have started essentially. That is where the course starts. One of the major challenges that the students faced as part of their monitoring process is encapsulated in this quote that I had from one of my students. He comes from a non-CS background, absolutely no coding background. He says that he feels anxious while trying to write code or trying to solve these problems because he doesn't know where to start. And the biggest fear is to make mistakes, right? And this is I don't know, I'm not making a generalized statement, but in general, in education, that last sentence is a very major fear that any student has. I don't want to make mistakes. Whereas in our everyday life as professionals now, we tend to make 10, 15 mistakes every day, and most of our days spent in problem solving or troubleshooting. So it's basically a whole approach shift that we are talking about. Okay. According to research, more non-CS students face more programming anxiety, where multiple studies have consistently shown that non-CS students will have a lot of starting difficulties with how to approach a problem, how to write code for that problem, and there is a lack of prior exposure, right? That's the gist of the problem. And of course, that leads to programming anxiety, and then that leads you to not being able to start at all. And that is the place where I wanted to, that is the place that I realized that I needed to work on in general. These are all studies that talk about this very effect. So, how I've handled this aspect in class? I've had a clear emphasis on paperwork. As in, if I give, the approach is very simple. I'll go to class, I'll take some time explaining the exact problem that we will be working on in class today, and I will basically let them ask me questions about the problem that we'll be working on all together, individually but all together. And the emphasis will be, let's try to solve the problem in pseudocode first. Let's try to flowchart the problem first. Let's try to find those breakpoints where that problem, where you might need to do something new, where you might need to divide the system into different processes. So the emphasis is on paperwork first. The emphasis is on trying to get to at least 50 to 60% of your work correct. Because once you're right on paper, there is more chance of you being right in code. Right? So that is the whole approach, essentially. And algorithms as a way of thinking or as a way of life. So one of the questions that we as a group had fun with was, how do you choose clothes for the day? So lots of creative answers. How do you clean your room? And those kind of questions. And then, of course, we have approaches like Polya, Engel, and basically I teach those approaches in GIST. and example-based analysis. And then trying to simplify those technical terms and keeping the mathematics away as well. Trying to make it as simple for them, just getting into the key of the terms. And I work a lot by creating parallels with music production. So I will talk about certain concepts as being very similar to EQ, being very similar to compression, or being very, very similar to frame-based work, and so on. And that is how I bring confidence into the algorithm design part of it. Because once they do this right, other things are all about syntax and trying to debug syntax. I can solve this problem on paper, at least. So any mistakes I make are syntactic and not logical. And again, very test-based. So check every line. If any line is making a mistake, you go the Hansel and Gretel way, basically, breadcrumbs. I make mistakes in class, and I usually take a problem that even I haven't solved, and I be vulnerable in class and make mistakes. This is something that has been going around a lot, AI in education, and I have seen students trying to use AI in solving code. Some of these students have also already vibe coded a lot of things that they've wanted to solve. But my approach has always been that you can use it, but first learn how to read the code and how to debug the code. So you can use it, but have an understanding of how to read what the code is doing and whether it's getting you the right output or not, and what are your parameters for success. Once you have those clear, you automatically get it in the right way. So in summary, there's a huge need to remove the anxiety and stress around writing code, and the whole crux of the situation is that algorithms and problem solving are very essential processes, and getting that right will help you get your code right at least up to 60 to 70% of the way. My inspirations have been, of course, Joshua Hodge and his wonderful work, Jan Wilczek's wonderful work as well at The Wolf Audio, Mad Cat Music's YouTube channel as well. I've seen a lot of these people trying to simplify code, and me bringing it into a classroom environment has been these shoulders of giants that I'm standing on, essentially. Thank you so much.
I think that's an amazing initiative that Milap is taking. We'll take a quick, we have some time for questions. Anyone?
You were mentioning using AI in audio development processes and like basically for audio related software. What would you say would be like key pointers developers would have to take note when using AI to like help them develop like say an audio software, like what they would have to keep in mind?
Actually, the Audio Wolf, Jan Wilczek has a beautiful write-up on this. The gist of the most important thing is that AI will develop the code for you to solve the problem, but it might not always develop optimized code. AI does not take care of issues like memory leaks or I would say other optimization related issues. So AI might, AI might help you even complete what your mental thought is while you're writing your code, but there's a very important need to be able to read between the lines and understand that, okay, this might be the line where I might have missed something out. I might have defined a constructor but not a destructor. AI does a lot of those things essentially. So it will write your code almost 60 to 75% right, but it will leave those gaps, those loopholes that you will have to sit down and understand. So right now AI in audio is at that stage where it will write you 70 to 80% of good code, but you'll spend more time debugging. And essentially it will make you spend more time than you would have spent essentially writing the same set of modules because of your skill. So.
Okay, so essentially like a developer would have to keep track of the life cycle of the objects they are defining.
Yes, okay. Life cycle as well as signal flows.
Okay, all right, thank you.
We had one more question. Oh, sorry. Yeah. Please go ahead.
Milap, you did answer one of the questions on how AI is. You answered how AI is evolving in the audio code development. The other question is, how do you relate your course to the music production?
So, as of now, I'm teaching them JUCE. So I'm essentially teaching them how to develop their own plugins. So a lot of the music producers' work is essentially using preset plugins to get the kind of effect that they're looking at. But what if a lot of these students or a lot of music producers may not have the money to buy a plugin that gives you what you want? What if you can just design and make it on your own? That is the kind of I would say that is the kind of problem that I'm trying to solve. You might not have the money to buy the whole Waves Gold bundle, for example, but if you're able to design a kind of limiter very similar to the L1, you are essentially solving that problem. And if you are able to design it, you also know what is the limit of that plugin. So then you know that I can tweak something here where in my way I've built it, I have a multipressor inside. So I have tweaked it in the high frequency range a little bit based on what I needed to do, based on the genre that I'm composing in. So that's the whole point.
Thank you, Milap.
All right, so that's all the time that we have for questions for this talk. But feel free to meet Milap again after this. Also, to mention, JUCE now also has a free official course to learn everything with the basics, which is available on the wolfacademy.com, which is also created by Jan Wilczek that Milap mentioned. I'll again mention this during the conclusion so that it's on the slides and you can make a note of the URL and all that if you want to get started. And definitely meet Milap because he's definitely taking a lot of effort to make sure that creatives can start developing too. So round of applause for Milap. Okay, so let's resume the live stream. Okay, all right, so our next presenter is Rob Myers from Avid. This is a big deal because when we started out like 2 years ago, we thought, okay, that we'll be able to capture attention of various industry leaders, but we never thought that Avid would show up for our event. So really excited about this talk. So Rob is a software engineer on the Pro Tools team at Avid, specializing in the AAX plugin platform and developer integrations. Rob will also be joined by Praveen and Shrijesh to explain about how Avid is collaborating with Global Logic to set up teams in India. So this talk title is Developing for Avid's Audio Ecosystem. Please give a round of applause for Rob.
Thanks, everyone. And I really feel lucky to be here, especially to be able to travel all the way here and meet all of you. Avid has participated in the ADC event in London before. If any of you have ever been there, we really appreciate that this exists, and it's just a fantastic series of events around the world. Like I said, I've traveled a long way here. I'm from Bellingham, city of Bellingham in Washington State in the United States. The theme or the motto of the city of Bellingham is the city of subdued excitement. So I'm going to do a little test here. Is everyone excited to be here today? Yes. Okay, good. You are exceeding subdued excitement, so that's very good. You're better than me. All right, so what am I going to talk to you about today? So I usually specialize in ADCx on the Pro Tools team. Everyone on the Pro Tools team who develops there kind of works in a lot of different areas. So I'm actually going to give you a high-level overview of a few different APIs that Avid makes available. And the general gist of this talk is to help you feel like these aren't really mysterious ways to connect to your products with Avid, but really to like reduce the barrier to entry. Because I know that interacting with Avid as a big company can be a little different. Almost everything else that people are going to talk to you about today is the entry point is like go to GitHub and git clone. It's not that way with Avid, and so I'm going to help you understand kind of what are the steps to get in. So we're talking about Yukon. We're going to talk about the Pro Tools scripting SDK, and we're going to talk about ADCx at the end. Hopefully I'll go fast enough that I can really dig in on that, because that's what I'm excited about. Okay, so just to set our frame of reference here, I hope everyone knows what Avid is and what we do in general, but I'm going to invite a guest speaker up. I'm going to invite Shri up from the solutions team at Avid to give more of a picture of why products that people like you make, products that are part of an ecosystem, are important to Avid, and why Avid is important to those products. So Shri, come on up and talk to us about that.
Thanks, Rob. Hi, my name is Srijesh Nair. I'm an audio application specialist for Avid based out of Dubai. So I handle the Middle East, the Indian subcontinent, the Central Europe, Turkey. So if you take a look at that on the map, it's a very interesting region as well. So my point is, what I do is I take care of demos, I talk through workshops, and I talk through workflows as well. The important part is, like, if you were to just look at the past 2 releases that Pro Tools had, so you can see we've got integration with not just in terms of plugins, we've also got it in terms of immersive mixing. So I'm sure you would have heard of Dolby Atmos. We've also got it with Sony 360, and there's also Audio Vivid that we have. We've also got another very cool integration with a company called SoundFlow, who makes scripts. That's the other part that Rob will talk about, is Pro Tools scripting. And they make excellent tools for macros that you can fire within Pro Tools and just create stuff out of your way and make life a lot more easier. So this is just Pro Tools 2510, and what we did in December was also a build-up on this. So you would also see like stuff like Bounce Factory Lite, which is a bounce mechanism from SoundFlow, and a lot of other plugins as well. What is also interesting, it's not just about the plugins. There's also something that's called the inner circle rewards that we have from Avid, wherein we push a lot of these plugins to the users who are on a support plan with us, which means they get to experience your plugins and the ones that you make in association with us. As in, like, it's not just important to make plugins, it's also important to see how it gets to the users and how they can benefit from that. Now, in that line, this is how I tend to do this as well, and this is how our team does it as well. We do demos, we do workshops. In fact, apart from being a product specialist, I'm also a film mixing engineer. So a lot of these stuff is also used in real life workflows. And when we talk about this to students, to professionals in conferences, trade shows, and all of these places, we talk about the real world application of these plugins. And they don't just see these plugins and these tools as simply as a demo, but they see it in a real world, real session application as well. So this is a context for Rob's talk and what happens once you associate it with Avid. So I'll hand it back to Rob. Thank you.
Thanks, Shri. And yeah, like you said, we have people going in front of customers in big and small events all over the world and showing off not just like putting Pro Tools on the screen, but putting Pro Tools and a bunch of plugins and like showing the entire workflow. So if you're interested in that, talk to Shri at one of the breaks. Okay, so the other thing before I really get into the main thrust of the talk here is to point out that Avid is hiring, and specifically, Avid is hiring right here in Bengaluru. So we are going to hear at the end of the presentation from GlobalLogic, and if you are interested in that, which I hope you are, please come to talk to us at the booth, okay? All right, so if you do fall asleep halfway through this because of my droning voice, I want you to know that building audio plugins and integrated apps with Avid products is free. I feel like I shouldn't have to express this because that information is not like hidden anywhere, but we've had a lot of questions over time where people come to us and say, well, I thought I had to like pay a bunch of money to Avid to like build one of these things. I don't know where it comes from, but I just want you to know that that is the case. there are some extra steps, like I said, for both developing, for getting in, and then for testing and signing your products and just making sure that they work securely with Avid's products. I'll talk about that later. And then if you have questions, there are actually a number of contact points with Avid and different URLs and things, and it's great if you remember all of those. If you don't remember all of those, then you can talk to me and my team at avid.developer.services@avid.com, and we can dispatch your question to the right subgroup within Avid. So if you have, if your Rolodex is 1 page long, put that on the page. Okay, now there's an asterisk, which maybe is where this confusion comes from. When I say free, what I mean is you're not paying Avid money to be a partner with Avid. You do still have to make a product and sign and notarize and staple your installers and stuff with Apple tool. You have to pay Apple something for that. And when you make an AX plugin, you'll have to sign that plugin, and there's some stuff you have to buy in order to do that. So there is a little bit of investment, but it's not very much, and it's not like there's some sort of a agreement where Avid's taking your money in order for you to be a partner. Okay, a great starting point. Like I said, you're not going to usually go and git clone any of these. So the place where you do go, the main portal, is developer.avid.com or developer.avid.com/audio for all of you. You will have to make an Avid account there, and then you'll get a menu of SDKs. You can go pick the SDK. There'll be a license agreement, which you should read. I say here, just click through it. Don't just click through it. Read what you're agreeing to. But it's essentially you're not going to make something that's really, really, really out of line for what this SDK is designed for. And then you can download it. You can download documentation, tools, and everything. Okay, so what can you actually build with any of this? First, I'm going to talk about UConn. So this is our control surface and command connectivity API. In particular, it allows Avid control surfaces and control apps to interact with your applications. So if you have an audio application that runs on Mac or Windows, then you can UConnize it. You can add the implementation or an adapter for the control layer of your application, and Avid control surfaces and tablet apps and things can connect with it. Because it's designed for audio applications, it has special features related to audio applications. So does it see? Yeah, hey, look at that. So here's a large format surface, an S6, I think, in the background here. And look, it's got an EQ curve that comes over UConn from the application that's being controlled. And it's got these scrolling waveforms, which are really cool. And those aren't normal, generic control protocol things, but they're in UConn. So yeah, it's essentially, and not just a control protocol, but an audio application control protocol. All right, so how do you get started? Same thing, we're gonna repeat this multiple times in the presentation. Go to developer.avid.com and download the SDK. Then, once you get the SDK, it's a heavily C++ object style interface. There are a bunch of classes inside of that, so what you will end up doing once you read the documentation and understand all of it is you're going to implement your control layer for your application in terms of a hierarchy of C++ objects. I guess, I don't have a really good analogy, but maybe a voice over control or command tree would be something similar. Those objects for UConn range from the top level, which is your whole application, and then you get down into things like arrays of knob cells like you would get on the control surface back here. This column here with the meters and all that stuff, those are described in terms of UConn objects. So it's also not a very generic protocol where you're just saying, I have all of these float values and tell the control surface to do something with them. You have a lot of control over how things get mapped out, but not full control because we have different formats of control surfaces and apps. And so UConn, the smarts of UConn is reformatting what you present into a shape that works well on all the control surfaces. You don't have to deal with those specific details. UConn takes care of it for you. All right, and then how do you actually test this and develop? Use the Avid Control app, which you get on your tablet, and you just test with it. And it's free, and so you can start today. Do it right now. I don't mind if you're on your laptop. We also, if you download the SDK, have some emulators for the large format consoles, because we assume that you don't have one of those at your house. If you do, that's great. Otherwise, you can run an emulation of it and just see what happens. So what does that actually look like in practice? Thank you, Avid Marketing. Here's a video. And the, that's fine. Basically, I mean, this is running Pro Tools, and obviously Pro Tools has like a deep integration with Yukon, but any application can do this. This is showing the Avid Control tablet app, which is what the user's interacting with. And then it's docked into a control surface we make called the S1, which sort of enhances the app experience and then gives you some physical controls. So essentially, like, if laying out your application in a way that a user would sensibly interact with it in these sorts of ways, like, makes sense, then Yukon's a good thing to consider. But even if it doesn't, Yukon also supports a type of control which gets mapped to like a soft key, like a macro key on the control surface, and the user is able to lock different applications to different parts of the control surface. So even if your application provides one function, but it's a really useful function for somebody, and they're always having to go back and forth and be in Pro Tools, and then they're like go over to your application and push the button, and then go back again, you can put that button in Yukon, and then the user can just like put that on their control surface and always have it there and not have to go back and forth. So that's also an application, another reason why an audio application in general, why you should consider it. Okay, let's move on to Pro Tools scripting library. So like I said, I've got 3 different areas here, and I'm just kind of going to give you a little bit of information about each one. And honestly, like if you want to dig deep into each one, the right thing to do is to go grab the documentation for it, because I can't really get into much here. But you can always talk to me afterwards. Also, I have like tons of bonus slides that I came up with and then had to rip out, so I'm happy to show you any more details about these. Okay, say it with me now. Download the SDK from developer.avid.com. That's where you start for all of these. And for Pro Tools scripting library, in this case, this API is based entirely around Google protocol buffers and gRPC. So there's a single protocol buffer definition file, ptsl.proto, and it defines all the messages, all the commands, all of the events you can monitor. It defines everything. And the actual RPC, I think there's like 2 functions, and we only mostly use one of the 2 of them. The actual RPC part is pretty lightweight. It's just a way to send the name of like the session ID so it knows who it's talking to, the command you're trying to run, and then a bunch of JSON that packs up all the arguments of that command. And then it's a streaming response. Well, I'll talk about that in a second. Then make a client, so make something that's going to be able to interact with this RPC system. In the case of Yukon, that kind of transport layer was getting delivered in some libraries that come with the SDK. In the case of Pro Tools scripting, it's just this protocol file. But there's a good reason for that, which is that there are many different languages. If you know protocol buffers, like you don't have to do C++. You can do, again, bonus slides. I have a completely working Rust example if you are interested in seeing that. So we come with a C++ client that does a little bit of bookkeeping for you. You don't have to use it, and it's pretty easy to look at the source code for that and see like, oh, those are the 3 things that it's keeping track of, and re-implement that in whatever language you want. Okay, and then again, you can start working on this. Again, if you want to open up your laptop and grab Pro Tools Intro, there are multiple versions of Pro Tools. Intro is the most feature-reduced one and the most cost-reduced one because it's free. So you can just start building a scripting app for Pro Tools, use Pro Tools Intro. You don't have to worry about figuring out how you're going to get like deeper involvement in Pro Tools. If you do, however, if you want a feature, if you want to interact with like an ambisonic, like a third-order ambisonics track, make something that works with that. You're not going to get that in Pro Tools Intro, so you can talk to us about having access to the features you need. Okay, so go into a little bit more detail here. I pretty much covered this already. There's a server that runs inside of Pro Tools. The protobuf layer, you're going to have a protobuf layer which is going to connect to that server, and you can use the C++ example in the SDK as a good starting point for that, or just develop in C++. And then your code is just going to interact with that, sending commands. All right, so here's a sequence diagram that I'm not going to walk through entirely, but actually the main reason I wanted to show this was to point out that each of these commands you send is actually an asynchronous command, and it's not just like a command response. It's a streaming request. And what that allows us to do is with basically a single RPC API, we can handle a lot of different circumstances. So you can treat this like a synchronous request. In the C++ client, it returns a future, which has the response JSON packed into it. So you can treat it as a synchronous request by just like send the command and then get the future. and wait for it to get done, and then you've got the response back. But you can also do things like have progress bars, because you can send the request and then have an optional callback, which happens as progress is happening. Your callback is getting great, and then like when you feel like you're done, you just call get on the future and pull the result out of it, and you'll block. Like, where is that? Where is my thing? You block your thread waiting for the future to complete. There it does. There's another thing which, if you looked at this early on, there was a feature we added in the middle of last year, which is subscribing to events. So you can find out what's going on in Pro Tools by sending this long-running streaming request, which basically never finishes, but it triggers that optional callback every time one of the events you're subscribed to happens. So we can, again, handle lots of different use cases with a pretty narrow API, which to me, as an API developer, I think it's cool. Okay, so here's an example. And this is a technology preview. This is something we're working on with Fraunhofer right now. And so no promises, because it's not shipping yet. But what's happening in this case is we have an AAX plugin, which is going to open an MPEG-H master file, which is a WAV file with a bunch of metadata inside. And it's an immersive format, so it's got lots of different channels representing tracks, it's got things representing objects, and it's got spatial positioning metadata for all those objects, all in that one WAV file. The plugin, in this case, wants to be able to, the reason it's a plugin is we want to be able to like render audio through it to the actual like Pro Tools monitor output, so someone doesn't have to go to a separate app and set up its monitoring solution. But what's happening here is the plugin is just going along and making the tracks. And then it's bringing in the audio files, and it's making the audio files, and it's putting the audio files on the tracks. And then it's putting the automation data for all the positional metadata onto the tracks. And then it's able to play back, and the user is able to hear what's going on through their Pro Tools monitoring environment. So anyway, look at that. Isn't that cool? I love it. So that's the kind of thing that you can do, even if you're making plugins, for example, and you think, how can I use this Pro Tools script? Often we try to divide the world of the responsibilities of a plugin. We often get questions like, well, I'm making this plugin, but what I really want to be able to do is like start the transport rolling from inside of my plugin. We think that's not really a responsibility of like an insert on the track. You have to like put the insert there in order to push a button to get your transport to start rolling. It's not the right workflow. But Pro Tools scripting, like you can put any workflow you want in there. So yeah, if you have ideas like that, things that are beyond the pale of just the plugin API, check Pro Tools scripting out, check the commands that are available, and we keep expanding it with each release of Pro Tools also. So if you looked before and a command wasn't available, or if you wanted that event monitoring system, look again, it might be there. All right. Wow, we're breezing through this. Great. AX is my area because I'm a developer on the Pro Tools team. If you don't know, it's Avid's plugin format. And why does Avid have a plugin format? Well, for one reason, we have a few unique requirements in order to get a consistent experience across multiple audio products. So this is used by Pro Tools. It's used by our Venue live sound platforms. And it's also used by Media Composer, our nonlinear video editor. So if you make an AAX plugin, to some extent, it can work with all three of those. In particular, like I said, we have some unique requirements. The Avid ecosystem includes products like our HDX PCIe cards, which have a big bucket of DSPs on them, and when you run a plugin, an AAX plugin on an HDX system, you can run it fully native, but you can also break it up and run part of it on those DSPs, which is great. It allows you to do very, very low. Actually, we have a Carbon sitting out there in the desk area, and it has the same type of topology on it. And I think that the audio throughput of the Carbon, because it's going directly from the converter straight over to the DSPs and straight back to the converter, it's like this ridiculously low latency, basically real time. And that's what we're able to achieve by taking the AAX plugins and breaking them apart and putting them, executing something remotely, like on a DSP, very, very close to the converters. And we have a few other DAW-specific features, like we saw with Yukon, there were those EQ curves. You can make an EQ curve for your AAX plugin and put it on the Yukon surface, for example. All right. So I want to talk a little bit more about that. Well, want to talk about what we were thinking about when we built ADCx, partly to explain, like if you're a JUCE developer, you might build a cross-format plugin, you might include ADCx with that. And by the way, ADCx is now included with JUCE, so before you had to like go and get it somewhere else and plug it in. Now it's just, you download JUCE and there's a copy of ADCx there, so know that, because that was a fairly recent thing. But you might be used to debugging in your code, like on your side of the JUCE adapter. But every now and then you'll have an issue and you'll have to go into the format-specific code. And I would like you to understand what is going on when you look at the ADCx part of that if you're doing something with Pro Tools. So let's think about what a plugin is. Here's a plugin. It's easy. There's like 3 points of connectivity. This could be a plugin. This could be like a node in a processing chain. This is something that processes audio in sort of an object-based universe. Essentially, what you need to be able to do is change its state, find out what its state is, because you probably want to display it somewhere, and process audio. Or process, it could actually, I should say, yeah, this is samples. It could be MIDI, it could be other stuff. It's real time, right? Something that interacts with the real world here on the bottom in a very like real-time, deadline-driven way. Okay, so let's look inside. Oh, look, it's easy. There are 2 blobs. You've got some state and some business logic that's connected with those connectivity points that are going to be like changing this. I know this is like, there's a reason why this is super abstract, and it's because I want it to be as broadly applicable as possible. So if I start adding special cases here, it's like, it looks like it's not applicable. This, basically everything needs to do this, right? At the bottom, you've got some kind of an algorithm that gets triggered. And, right, like, you want to connect that. Like, you don't want your algorithm to live in an island. You want it to react to changes in state. So you connect the 2 of them. Why is that line red? Why can't you just do that? I was trying to find an example from Clap, and I was like, if anyone's an expert in Clap, please come talk to me later, because I would like to understand. JUCE is a much better example of this. Here's a filter class from JUCE. And like, it's up to the caller to ensure that these coefficients are modified in a thread-safe way on every single object, right? Like every blob that you encapsulate as an object has 2 things it's doing. And what's an object? What's a class? A class is some program code, right? It's the same program. Like every instance of the class is every object, same program code, and it's connected to some data. So the responsibility of the class is to have some program code that operates on this pointer that's like pointed to that data, which is your object. Okay, so so let's add some synchronization, right? That's what we need. And okay, so something I didn't talk about was obviously on the bottom, we're entering into this green blob through a thread. It's a special thread. It's a real-time thread. It has some constraints, and you really, really, really don't want to block that thread. Like really. You don't want to have a mutex on that thread. You pretty much just want to have atomic bools or primitives on the thread. And you don't want to spin. You don't want to do anything on that thread that sounds like something that you don't know how long it takes. So this synchronization is a special kind of synchronization. It is non-blocking, real-time, thread-safe synchronization, which basically requires, well, again, if anyone has a much better solution for this, come talk to me. In my world, it pretty much means you have a copy of the data, right? You have a ping pong buffer, you have something like that. You basically have to have a copy of the data that the algorithm thread is going to interact with. Oh, I drew the arrows going that way, going down. I recognize they go the other way too, like you get meter data going back and forth. So I don't know, imagine you have 2 synchronization mechanisms here, but both of them are designed such that the real-time thread doesn't get held off. Okay, let's review. What's an object, right? What's a class? It's some program code and some state. now we have, like, what do we have? We've got two of those. We've got two program codes and two states. So we don't draw the boundary around the whole thing. Like in practice, like you can draw the boundaries around the whole thing, but in practice, in your code, the logic of your code, I bet, has two distinct classes, even if it's just one class. It has like two distinct control flow islands inside of one class. Okay, so remember I said that ADCx supports remoting essentially that bottom part of the plugin design. So I drew these boundaries with the synchronization part outside, because if we want to send data between systems, like to our DSP chips, we do need a pretty consistent way to achieve the synchronization. When we're sending data from one place to another, we need an API for that, basically. So this is drawn the way that it works in ADCx. You don't have to draw the boundaries that way, but it works for my narrative, so I'm going to do it. Okay, so again, in ADCx, this is where if you're getting into debugging your plugin and you're wondering, why does the ADCx code look like this? This is weird. Why does it need this coefficient block that goes into the algorithm? That's the reason. The host is responsible. These are all pointers. The host, oh, you can't see my cursor. These are all pointers. And so this structure is just a list of pointers, pointer 1, pointer 2, pointer 0, pointer 1, pointer 2. The host is responsible for filling the data behind all those pointers every time it calls the algorithm. We've got some audio inputs and outputs. The host is going to fill those. It's going to call the algorithm of audio inputs. This is the part that is essentially the thing we were talking about before in that JUCE filter. Here's data that the algorithm for the filter, and this is copied from Avid's EQ plugin that comes with Pro Tools. So here are all the coefficients for that. And then usually you're going to need some kind of like data, some memory allocation. For ADCx, all of the data that the algorithm uses is managed by the host. So these are blobs where the plugin had said, I'm going to need a K of memory, please. And the host will allocate that and then give you a pointer to it. So kind of like, this is the result of your malloc. And then, like I said, things go the other direction, so here's a buffer for meters. So that's basically, like, if you look at any ADCx algorithm, that's what you're going to see. The prototype is the same for all of these callbacks. It's just void, void star, void star. The first void star is a pointer to your coefficient block. Like, the type of that is this list of pointers that you've told the host about. And then the second one is just the end of, it's an array of them, so the second one is the end of that array. All right, so there's more stuff. This is the ADCx documentation page, and particularly I wanted to show that if you, yeah, sorry, let me orient you here. So if you open up the ADCx documentation, you'll get to this page, and if you go to the manual within this page, there are a lot of different pages and topics and things if you're interested in particular areas or if you're debugging an issue particularly with your plugin. And I highly recommend, because I wasn't able to get into it in detail in this talk today, but I wanted to, I highly recommend looking at the parameter update sequence area. All this, because the other half of this story, like I've only told you half the story, which is breaking up the algorithm part. The other half is what happens when the user touches something in the GUI. How does that actually get everywhere it needs to go? How does it get synchronized? How does it get delivered at the right moment? Let's say we're playing back automation, so you're like pre-rolling it. And again, remember that red line. If you pre-roll automation at the top half, you don't want the bottom half to like immediately change the state because it's at the wrong time. So how does that all work? It's described there. So if you're interested in it, take a look. Okay. I think we've got extra time. So like I said at the beginning, you are going to acquire these tools with a few extra steps. And especially if you're getting to the point of building a product and deploying it and putting it in front of customers. For ADCx, there are just a couple of extra steps, so I want to talk about those. But first, we do the thing that we talked about for Yukon and for Pro Tools scripting. We'll sign up for the AX SDK, developer.avid.com, and then download the SDK, look at the documentation. Oh, there are some tools also available, so you'll have access to a command line runner for AX plugins, what's called a page table editor to make a resource file that goes with your plugin and allows it to map successfully to Yukon surfaces. There are a few other things that you get at this stage. And some of the things that are there are builds of Pro Tools. But you can't use builds of Pro Tools yet because you don't have licenses, so you're going to have to talk to us to get licenses. In particular, you'll want a build of Pro Tools that lets you debug your plugin. Those are called developer builds. And in order to get access to those, you'll have to send an email to us, in this case, or the right email to remember is called devauth, for developer authorizations, at avid.com. And then within a few days, they'll review your request and hopefully send you some licenses. But we do want the human touch point here because, you know, we want to know who you are and what you're working on before we're just handing out licenses. So they'll get licenses back to you. And again, if you forget that email address, talk to my team, Avid Developer Services at avid.com. Okay, great. So now you've got some licenses, and you can build and test your plugin. You can debug it. You can even check it with like beta builds and make sure they're compatible. Cool. Next, well, actually, I said you could test it with beta builds. When you try to test it with beta builds or with shipping builds of Pro Tools, you will find that you hit a wall because it's not going to be signed correctly to run in those builds. So AX plugins have a particular signing requirement. We license some tools from Pace that allow us to have a fairly tightly controlled certificate authority for these signatures and signing process. So you will again have to talk to us. This is another email address for you to remember, audiosdk@avid.com. That is not just for requesting the signing tools, it's basically the partnering team at Avid. So if you're interested in any particular kind of business partnership, or even like getting into demos, things like that, this is a great email just to remember to connect with the people at Avid who do that specifically. But you know, they also handle these requests for the signing tools. Again, we want a human on the other side of that who can look at your product or hear your description of it, or just like make sure you're a real, legitimate company. Okay, so we are going to take your request. We're going to send a message over to Pace and say, hey, Pace, please provide the tools to this person. And then they'll do it. Great. Remember at the very beginning, I said that this is all free. Here's one of those asterisks. The tools that we license reside on, I don't have one here, but it requires a physical iLock USB device. So that's like a thing you would have to buy if you want to go through this flow. There are also cloud-based signing tools that Pace provides, but you have to get those directly from Pace. It does the same thing in the end, but like if your CI/CD flow and your production and deployment flow is entirely cloud-based, or like you rent space on a VM or something like that, you know, you're going to run into the fact that you can't plug a physical key into those. So just be aware. You'll hit a issue at that point in the process and talk to Pace, and you'll sort it out with them because they do have a solution for it. Okay, so that covers everything that I wanted to talk about, again, at a high level, skipping through these 3 APIs, and I'm happy to talk in greater detail about any of them with you. I'm sure I'll have some questions. But I also want to give space because I think possibly the most important part of any of this is that if you want to come work on the team at Pro Tools doing this sort of thing, I would love to talk to you. So we're going to have Praveen come up from Global Logic and tell you more about how you can do that.
Thanks, Rob. And good to be here. Good afternoon. I know we are getting closer to lunch, so I'll try not to hold you guys for a long time. But yeah, hearing what Rob just explained to what I'm going to talk about now is the journey of how we built the Avid lab at Bangalore at Global Logic, right? So first, before I go there, I'm a director of engineering at Global Logic. More than 2 decades of IT industry experience into product engineering, program delivery, building teams, all of that. And I've been with Global Logic for the last 4 years.
particularly working for the media and entertainment delivery unit, and working with a lot of customers in the media and entertainment space. Avid is one of those major engagements I'm driving. First of all, what is GlobalLogic? Who is GlobalLogic? GlobalLogic is part of the Hitachi group. Hitachi needs no introduction. Big conglomerate with more than 150 organizations or companies worldwide, from Hitachi Nuclear, Hitachi Energy, and whatnot, Hitachi Rail, whatnot. The security and access token systems we use in the metro in Bangalore are from Hitachi, right? So needs no introduction. So 4 years back, we went into the Hitachi family, and we are the digital product engineering service providers to a majority of the organizations in the world. So this is who we are. More than 32,000 employees all over the world, with half of them in India, working with a lot of customers, private label customers, public limited companies, all of them. Avid is one of these 119 private label customers we work with, and we have built an engineering lab for Avid. I'll talk about more of that towards the last, but this is who we are. We have an office in Bangalore, and we have 5 or 6 centers all over India working for all these customers. Coming to the work we do at the Media and Entertainment Delivery Unit, or a Center of Excellence in India, we have more than 3,000 engineers who come from a traditional IT development and QA and DevOps and all of those kind of streams, but particularly expertise and specialized on the media and entertainment space. If you imagine, because all of you are from the community, I'm sure you all understand, media and entertainment has 3 separate aspects. One is content creation and post-production. Then the second one is content processing. And the third one is content distribution. At GlobalLogic, we work with all the 3 areas with a variety of customers and do a lot of engineering work for all these customers. Coming to post-production and pre-production, that is where we work extensively with Avid on products like Pro Tools, Carbon, Media Composer, many of them, right? We have been working with Avid since ages on all of these products, and GlobalLogic has significantly contributed to these products. We work with some of the organizations which help curate the content, add captions, do multiple format conversions, language conversions. That's mostly in the pre-production and post-production space. We also work with a lot of customers, mostly on the hyperscalers, on the cloud service providers, where a lot of these platforms are based. We help deploy, we help maintain, we help engineer those platforms for scale on the cloud, right? Recently, one of the major OTT providers did a rejig of their application, and our teams helped test that product on 14 different platforms, simulating a peak workload for 20 million subscribers when they were just going live. So this is just an example of the kind of work we do. And we also work with a majority of service providers, the network service providers, and we work on the engineering and integration of all these products on those networks. And finally, coming to the distribution, we work with the TV manufacturers, build their TV operating systems from the firmware till the application and cloud deployment side. And we also work with a lot of OTT streaming and traditional broadcasting providers, building the applications and engineering all of them on their workflows. So at GlobalLogic, we have a lot of expertise working on all these areas, doing engineering across firmware, middleware, and the application side. and definitely we are always on the lookout for talent who can come in with that right media industry background and come with the necessary technical skill set to join our team and help work with customers like Avid and build their products of the future. So that is what is Global Logic. Coming to Avid in particular, Avid is one of those 119 private label labs I had just mentioned in one of the other side. We have our teams working for Avid across the globe, be in South America, be in Central Eastern Europe or Europe, and now in Asia Pacific. For the last 2 years, we have been building the engineering team for Avid in particular. We have now people working in India on all these 4 areas of the product lines Avid has, be it professional audio solutions like Pro Tools, working on audio interfaces, working on control surfaces. We have people working on the Sibelius and Avid Place, the distribution and integration side of it. We have video editing and post-production team working on the likes of Media Composer SDKs, the Nexus storage devices, the edit on demand and the Wolf Text and all of those aspects. We are also working on the broadcasting side of it, the live sports and news broadcasting with the likes of Media Central and the new product which Avid is planning and where the lot of energies of Avid and Global Logic are deployed today, which is Content Core, which actually got previewed on IBC last year and even on NAB that is going to be demonstrated. So looking back at the last 2 years, right, some of the challenges we really faced were finding talent which has that creative bent. I think Milap was also talking about it. There are 2 kind of people we have, right, in the industry. One is people with a creative bent, come from that really music background, passionate about music, and then the IT engineers who come with that traditional C++, Java and whatnot, all that skill set. How to find the particular challenge we faced when we were building the Avid team was how to find that engineering talent which is passionate about music. And then bring that talent and then start working on Avid. So like when we found or when we were looking for the QA team, when we were looking for setting up the Pro Tools QA team, we really had to look for sound engineering professionals who had done sound engineering, who had done recording, who have done post-production, and then bring them into a traditional IT space and form that QA team so that they have the context of the industry, how industry uses the products, how they have been using it to earn their livelihood, and then marry that with an IT release or software delivery lifecycle. So we went through those journeys. One thing we really noticed was there is a lot of passion and energy, and a lot of people from the industry wanted to join our team, but the real challenge was finding the right talent who could come in and fit into the IT space and get integrated with our engineering teams. So we have managed to overcome that, and now we are, I think, ready to launch, and a lot of expansion is going to happen. We are always on the lookout for right talent. So definitely we have a booth. We have our engineers who have been through that journey for the last 2 years. They are on the booth. Please feel free to interact with them, and we will be happy to hear you out.
Thank you, and I've got one more thing because we have time, and it's fun. It's apropos of nothing. It's like not anything that I talked about there, but I was planning this talk. We had a hackathon at the Pro Tools team, which is like the best. We take a week, and people set aside their normal work and work on whatever they want. All right, so we had one developer. I was going to show you mine because it's actually relevant to Pro Tools, but then somebody else did something cooler, so I'll show you that instead. One developer was working on performance in the Pro Tools timeline. So the Pro Tools timeline has a lot of stuff going on. It's got lots of tracks, and he was looking at performance of rendering clips, rendering graphically, not sound. And how do we make sure that that can go really fast? Because the whole timeline could be like scrolling along, you have a big post-production session, it's got lots and lots and lots of these on the screen. So his hackathon project was around that. And in order to test that, he had to make a lot of tracks. And he had to make a lot of clips, right? And if you're a programmer and you're developing something that has a lot of little points that you want to draw, then obviously what you do is treat them as pixels and do what all developers do. So I just thought this was hilarious. Here we go. These are clips in Pro Tools playing Doom. Anyway, he's going to get through the level quite quickly here. Does anyone have any questions? How did that sound? It sounded like Doom, because he actually, he made this whole rendering engine and then also had the ability to connect to a core audio device from, anyway, it was what he worked on for a week, so it sounded great. We were like talking on Teams one evening, it was like 2 a.m. for him. We're like, oh, Carlos, you shouldn't be working this late. He said, no, I'm playing Doom. That's all in Pro Tools, that's all I'm doing. Yeah.
All right, round of applause for Rob, Praveen, and Srijesh. All right, let's take some questions. I saw one hand raised, yeah.
Hey, lovely presentation. One of the questions I had was when you talked about the graphical aspects of AAX and thinking as a JUCE developer. Sometimes you prefer the way JUCE interacts with its data. So is there does the AAX graphical protocol sit on top of that, or is it more cross, so you can actually use JUCE's methods as well as and so on?
Yeah, so interestingly, all of Avid's AAX plugins are built with JUCE GUIs. And so we adapt between the JUCE system. We don't build with JUCE like as a framework overall. But yeah, it does work. Essentially, the graphical API for AAX is like a pointer to a handle, which is the frame inside of the window that lives in Pro Tools or Media Composer. There's more to it than that, because actually some of the special features of AAX involve interactions. There's like a delegate class you can call. So if you mouse over one of the parameters in a plugin, you can actually have something on a connected Yukon surface. You mouse over the parameter. There's a special delegate you can call that tells the host, I moused over the parameter now. And then we've integrated that with Yukon surfaces, so you can actually like have a fader on the surface, which is just following whatever you mouse around, which is great. Like, it works really well. And if you're only developing with a JUCE API, like I don't think that feature, that specific one, is present there. So you may want to look and see what specific function calls there are. But other than that, yeah, it works great. Yeah, thanks for the question.
Okay, any other questions? Yeah, 1 second.
What is your take on like AI plugins and like music and stuff? Like, how do you think that trend would like progress? Because Ableton has done a little bit on that. I think a lot of DAWs are catching on to that. So how do you think, how do you think y'all would like do in that field? Like, what are the ideas that you'd have?
Yeah, so I think there are different aspects to how that question can go. So first, Avid has a white paper and a agreement that we go into with anyone who's in the generative AI space related to responsible use of AI. So I just want to say that up front. That's not really what your question's about, but Avid is doing our best to be responsible in terms of generating material. Beyond that, a lot of the work that's being done in terms of generative AI is being done by smaller and individual companies at this point in time, and it's like in a research phase. So Avid is doing some of that research, but we also recognize that a lot of the best solutions are going to come from you all. Like, they're going to come from people who are really investing their time kind of academically in the space. So we're doing the same thing that we often do with any emerging technology, which is to talk to the people who are the experts in it and to see what products they're building. Like Sri talked about Splice, for example. Splice has an AI-driven content matching system. So you can, like, here's my clip. Now find me some stuff that sounds good with it. And it's cool. It's not, it's different than some other solutions, like where you want to create an entire audio track for a film or something like that. They're different applications. So sorry, it's such a broad field that I can't really cover all of it, but those are the areas where Avid's paying attention. We're paying attention to who is the best-in-class producer of all these different categories, and doing our best to talk to them, and then also doing our best to, as much as possible as the situation evolves with generative AI, to be responsible in that space. Like, and that's a real, especially because our clients range from people doing this as a hobby to people who are running NBC. Like, we have to be respectful of the people who are running NBC at the same time that we're respectful of the people who are trying to just like do something cool, right? Yeah, so it's a challenging topic.
All right, any other question?
It was really a nice presentation. So how could we integrate our generative AI with C++ for getting a reliable outcome?
How do you integrate what to get a reliable outcome?
We use C++ here, and we also use generative AI.
Oh, I see.
So how could we integrate that?
Do you mean like given a prompt to get the same result each time, the same synthesized audio, or do you mean more like in terms of latency to get like a real-time result from a generative AI system?
Real time.
I asked that clarifying question knowing that, in fact, I don't have an answer to either of those specific details. I'm not sure. It's a real challenge to, like, given the hardware side of how this all works, it's a real challenge to get like a real-time system working on a GPU, basically. So even if you're not doing something generative, even if you're just running, maybe some of you have done research in this area, if you're just trying to run a signal graph on an NVIDIA GPU, like that alone is hard because you don't know when you're going to get any particular part of the answer out. So that's as much as I know to answer that question. I'm sorry, I don't really have a good answer.
All right, there's one question there as well.
Hi, thanks for the talk. Great presentation. The question I had was the plugins that you demonstrated here are like completely software based, right? So you write them in C++ or something.
Yeah.
Can you maybe create a plugin in, say, hardware? Like I take a Raspberry Pi and code up something on it, and can it then connect to your software in the way that it takes input from like a USB or UART or something?
Yeah, it's possible. There are some challenges with latency because that kind of a product would not be directly integrated with the audio device.
Correct.
And even if it was, so I can give an example to you of a cool product that McDSP makes, which is an analog processing box, which basically you have a plugin in Pro Tools and it exports the audio out to that box and then it brings it back in again. So they have a full analog signal chain in it, which is great. And we've worked with them a lot to solve some of the challenges around that because the plugins, they get that callback that is abstracted from the audio device. You're not getting an IO proc. You're getting this like algorithm thing with an audio buffer, which has been managed by Pro Tools. So one of the, this is I'm going to go on a slight tangent, but it's going to be illuminating for answering the question. Sure. One of the characteristics of AAX, as opposed to other plugin platforms, is that you're not iterating through a sequence of timestamp control changes in your algorithm, like you might with VST. You just get called with the data that you're supposed to process at that moment. The way that we handle timing and timestamping on the host side is that, let's say you've got like 1,000 samples coming up, and there's a control change that is timestamped for like 30 samples in or 60 samples in. We divide up that whole audio buffer into segments. So you might get called with like 32 samples, and then 32 samples again, but with a different coefficient block. And then you'll be called with a bunch of other like powers of 2 to make up the rest of your hardware buffer of 1024. So the specific, like the real-time, real-world clock timing of those calls is going to look weird, because it's not like 32 samples and we wait for the next 32 samples. We already have all 1024 samples queued up. We're just going to run them as fast as possible. So the challenges with that kind of a design are usually the fact that you don't know the real-time, like wall clock timing of the events that you're going to get for rendering, and the system that you're connecting with is going to have an audio driver, which very much cares about the real-world time, and it's like every 1024 samples for it is like literally 1024 samples of time. So yes, you can build a system like that, but it's not so much about AAX, but it's more about like the fact that it's so abstracted from the hardware that makes, basically you'll end up with a lot of buffering and a good amount of latency, but you can get, given enough latency, you can get the information in and out, no problem.
So the solution kind of what you're saying is it lies outside of your software and it lies in like in the kernel driver or something that you can write to actually interact with the device and get the 1024 buffer.
Yeah, it's
in a way, yeah.
There are some other challenges as well, which involves the you'd essentially have to have a live input, live output in order to interact with that hardware, because there's no way to like it's not coming from a track, it's coming from hardware. But as long as you've got it in a live signal chain, and you might have to talk to like have some user workflow involving set your playback engine to this, like match the buffer sizes or something like that, then you've gotten most of the way there.
Okay, got it. Thank you.
All right, that's all the time that we have for questions for now. Please feel free to meet Rob later on, and also the sponsors booth, which is there outside. You can meet the Avid team, you can meet the Global Logic team, get to know what they are building. They're also hiring, like Rob mentioned. I have a quick question for the audience. What's the URL of the website where you can get the SDK? Can you all just please say it out loud? Okay, nice. Is it developer or developers?
I should have a slide now. Yeah.
All right, so anyways, like meet Rob again, and please do sign up, because this actually a very, the response from Avid is actually very quick. I have like some plugins which are already out. I work with Soundly. I'll not plug that in here, but they're actually very responsive in like helping you out with your questions and scenarios. So definitely sign up, understand what the ecosystem is, and you can actually see the products in the booth there and see how the plugins are. If somebody is very new to plugins, see that in action, hear it in action, so you understand what this is, and 100% you will actually feel like making one for yourself as well. So with that, let's give a round of applause to Team Avid. driving AI-powered pro audio and embedded Linux innovation on next-gen SoCs. Vishnu will be giving a talk titled Linux as the Conductor, driving precompiled audio DSP kernels on C7X for real-time processing. Please give a round of applause for Vishnu.
Okay. Thank you, Prashant and ADC team for having me here. Okay. So I'm Vishnu from Texas Instruments. Basically, I drive the Linux audio on Sitara MPU platforms in TI. Right? So this talk, basically, some of you may feel that, okay, this is a little more on the hardware oriented, but I'll try to keep little simple so that everyone understand that, right? So here there are a few terms on the subject itself, C7X. So C7X is nothing but a DSP, which is from the Texas Instrument, which has basically vector core and the MMA core for DSP processing, as well as your neural processing unit is there. Okay. Okay, so few things about TI. We are the upstream first vision we have. Most of the things we do with upstream. Most of our code is available in open source. We work with the different open source partners like Linux Foundation, Yocto, then we have the OpenAMP, Jyfer, OpenCL, KernelCL, all those things we work. So agenda for today's talk is that first we talk about what is the problem statement which we are trying to solve, what is the proposed solution, the software architecture of the proposed solution, and one example we will take how the Linux controlled multi-channel audio we are offloading to DSP and how we are basically measuring the performance, the improvements we are seeing over there. And then we'll talk about the current status, what we have, and what is the next plan for that. And at the end, we go for the Q&A. Some disclaimer, basically, this is the, as you say, it's a technology presentation. It's not for the product readiness or roadmap commitment. Opinions here, whatever we are presenting, it's speaker opinion, not the TI itself, right? And some of the visuals which are there in this PPT is basically generated using AI tools. However, all the performance data is based on the actual measurement results. Okay, so let's talk about the problem statement. See, this talk is about how we offload the compute on the DSP, whether this compute we do on the ARM core itself or we do on the DSP. There is certain problems if we do on ARM only and if we do only on the DSP only, right? So first thing is that when you are doing it on ARM, right? So the inefficient CPU usage. Basically, ARM is not designed for the high compute real-time workloads, which basically leads to high CPU usage, right? So that is the one problem where we cannot run all our DSP algorithms on ARM core itself. Right? Second problem, if you are using Linux with DSP, so there is like different basically complex integration involves when you are doing this. So that basically when you are interfacing the Linux with the DSP, it involves custom IPCs, or memory handling is the problem, the synchronization, all those are very complex. So in this talk, basically, we are trying to propose a solution which can simplify all these things, right? The second is the poor scalability, right? So system is basically bound to your CPU usage, right? When you have the multi-channel or audio or whatever, it takes like too much bandwidth of the CPU, and it may not be available for, let's say, the graphics, your UI, or the control, all those things, right? So that's where it is basically limiting the performance or the scalability for DSP algorithms running on the DSP. The next is the inefficient data movement. Since we have to offload let's say, your audio processing to DSP, then you have to move the audio data to DSP, which basically is problem because you have to create multiple copies or unmanaged buffers, which will involve your latency, overhead, all such things over there. The next is the underutilization of the DSP resources. DSP core basically is there, but they are underused due to integration difficulty, lack of simple workflows. Because if I want something to use from the Linux or ARM core, it on that time not highly utilize the DSP cores resources, right? So that's the problem. So what we are trying to see, existing solution usually trade off simplicity for performance. The problem is not here the DSP compute availability. It's basically making the DSP compute usable from Linux in a simpler way with keeping the performance and latency at the same time. Okay. Let's talk about the proposed solution. So where Linux controls, you have the network, you have the display, you have the, your ADC, DAX, all those things there. So Linux here controls all those things. You have the control, which is on your GUI. You want to control, turn off a specific filter. You want to turn off the EQ. All those things you can do using the Linux control, right? DSP role here is just to accelerate, right? Whatever the DSP algorithm you want to process, let's say you want to do the noise cancellation, right? Noise removal, all those things you can give it to DSP so that it can just accelerate those things and give you the result, which you can use on the Linux side on your application. So core idea here, as I said, so Linux we are keeping as an orchestrator, and DSP is basically to compute the accelerator. So we separate here in two parts, the control and the data plane. So control plane is basically on the Linux, and the data plane is basically your shared memory, where the data is copied or sent to the DSP using the shared DMA buffer memory. If you see this diagram, basically you have the A core where your Linux application is running. You have the different framework like ALSA framework, and then we have the RP message DMA library. So this is the very thin library which basically provide you the control information where you, and buffer management. This is used for the communication between ARM and your DSP using the RP message or RPC, whatever you say. And it allocates and manages the shared DMA buffers, which is used for the data transferring between A core and your DSP. It handles synchronization and low latency messaging, right? So here in this, we are basically emphasizing on the zero copy buffer. We don't want to have the multiple copies when we are sending from the Linux to DSP. It's a single buffer where the Linux or your application will write that to DMA buffer. It notifies to the DSP using the RP message. It's just notification. You see the control plane is here. It just notifies, okay? There is no actual data transfer happening from A core to Linux core, right? So DSP basically, once it receives that, the RP message or control message, it basically copies the data from this shared DMA buffer to L2S RAM. So here one important thing why the L2S RAM is coming. It is internal RAM to DSP, so it basically improved the overall compute performance. So that's the reason this is copied here for internally, right? So DSP, when it executes the signal channel chain, it basically executes in the L2S RAM. Once it is done, right, it copies back the data to the same DMA buffer and notifies to the A core that the processing is complete, right? So this is how the overall things are here, right? So what is the advantage of using this? What problems we are solving, right? So there is no need of moving any application logic from your Linux application or Linux side to DSP. Everything remains same. Only the control path and the messaging part will take care of the offloading to DSP, right? So we can reuse the pre-built DSP kernels. So whatever the DSP kernels are there, you can just pre-build and use it. There is no what you say runtime DSP kernel compilation or happening in the DSP side, right? As I said, it's a zero copy buffer model, so no redundant ARM or plus DSP copies are made. It's a single buffer, so that saves the memory as well. With this, we can achieve the deterministic low latency processing. So the processing latency is still remain the same in this case, right? It's a clean, reusable, and heterogeneous compute platform, right? So we have the different heterogeneous platforms available where you can, using this simple framework, you can achieve the deterministic low latency processing for your workloads. Right? So let's talk about the software architecture, right? How it is there. As I said, you'll have the Linux user space here where you have the audio applications running, where you have the audio pipeline using ALSA, GStreamer, or custom app, whatever is there. And then basically in this architecture, I'm showing when you are offloading the audio data to DSP for processing. Right? So if you see this application is for in the copying the data to the shared memory. Right? And here we have a very thin, lightweight TIRP message DMA library, right? Which basically allocate the DMA-capable shared memory buffer in DTR. It manages the RP message control and enable the zero copy audio transfer and handle the synchronization, right? So this
library talks to your Linux kernel drivers, where we have the remote proc RP message drivers, which basically talks to the DSP core, right? And the DSP core side, DSP firmware, which is running on the C7X, as I said, it's a TI-owned DSP, right? And then which will basically receive the RP message notification, and at the same time, it will also send the RP message back to the Linux system, TI RP message library and back to the application. So once it receives the DSP firmware, basically receives the notification to do the processing, DSP will have your audio DSP kernels, where you have the signal chains, where it will do the copy that audio data from the shared memory buffer to L2S RAM, and then it does the processing and write back the processed data to the shared DDR, and then basically your DSP firmware will notify back using the RP message. So if you see here, we are clearly dividing the control plane and data plane in this architecture. So here the control plane, you can see this is there, and your data plane is completely separate. It's not in one plane, and there is no copy of data or anything happening in this one from the your Linux side, A core side to C7 side. It's a shared DMA buffer where everything gets done and there. Right? Okay, so let's take one example over here to demonstrate how these things are working. Right? So I'll take the Linux control multi-channel audio offload filtering example. So when I say multi-channel, in this example, we are doing the 8-channel audio. If you run this on the normal ARM, you will have the very high latency, and that's what we are trying to achieve. The latency should be reduced, and as well as the load of the ARM core should be reduced, right? For this particular example, we have used the TI M62D EVM SoC. So what exactly is this one? So this is the 62D is basically a premium audio and signal processing SoC, which has the basically for the premium audio, you can connect the Class D amplifiers on this 16-channel Class D amplifiers. It has onboard basically 4 DAC and 2 ADCs, which supports onboard 8-channel recording as well as 8-channel playback. It has the Cortex A53 running Linux. It has the C7X Vector Plus, Vector DSP Plus. We have the NPU, which runs on 2 tops available in this one. It has the R5 cores, which is basically for real-time control, device management, and as I said, the Mac ASP interfaces for multiple audio to support. So in this device, we can have, theoretically, we can have the 16 plus 16 channel audio. So hopefully this is visible, yeah. So this is one of the example I will quickly show. Here, basically, the A core application, it will read the 8-channel audio from the SD card. It can be directly from the 8-channel the ADC ports. It reads the data. It basically sends, is basically copy the data to the DMA buffer, whatever shared DMA buffer is there. Then it's using RP message. It's sent to C7. C7 basically receives on acknowledgement. It basically copies the DMA buffer data to L2S RAM. Then it executes the signal chain. And then after execution, it basically copy back the data from L2S RAM to DMA buffer, and then it notify using RP message back to A core, where this A core can basically play the data, 8-channel data, to the DACs available over here. At the same time, if you see here, we have the RJ45 or serial connection, using which basically we can monitor and control the operations on DSP. We can see the live throughput, what's happening on the ARM, what is the latency, what is the DSP usage, all those information over here. So let's talk a little bit on the signal chain, what we are executing over here. So here, once the data is received on the C7 side, right, it basically converts sort to float. It has the cascade bichord low-pass filter with the cutoff frequency of 10 kilohertz. And after that processing of this filter, it's sent to the high-pass filter, which is basically 2 kilohertz cutoff frequency. And then it uses the matrix transpose and then send it to FIR, low-pass filter with the cutoff frequency of 8 kilohertz. And then it does the real FFT and then IFFT and matrix transpose and the float to short. And after that, this data is copied back to DDR so that the Linux can basically use this data to directly to play. Right, so before that, I will just see if I can show you the
real example, right? How it is there. So, sorry, it's connected to VPN, so it may be a little slow. I'm just trying to run the application, the Linux M620 EVM, right? And this is basically connected to the host machine visualization tool. So here, you can see this is the 8 channel. Right now we are displaying the 1 channel data over here. So, one second, it's not visible. Okay. Okay. I'm not sure what is the issue. Okay, not sure why it is not displaying, but. Oh, okay. Yeah, let me quickly see, sorry. Okay, so you cannot hear the audio because this is connected on the my setup where the it will be playing on the board, so you cannot hear the audio. But here you can see the live, basically the how many frames you are processing, what is the latency, the amplitude, CPU load, DSP load, right? And at the same time, it has the control of basically you can turn on or turn off the filtering operation, which is basically the DSP operation, right? So let me quickly do the turn off. Sorry. Okay. Okay. So now the filtering is off, right? Okay. Just a second. Let me quickly run. Sorry for this. So yeah, now it's running. I will just see this control. Okay. So you can see here now this it is turned off the DSP execution. Now you can see basically the load get higher on the CPU side, and the DSP load will basically get 0. And if I do again the now you can see the amplitude over here, right? When it was running on the ARM, it was fully there. Now it's basically the filtering is happening. You can see this ARM amplitude was getting lower there, right? Sorry, this is because of the VPN connection, it's getting slow. So I'll come back over here. This all information is available on our documentation part for the 6-2D example. Okay. Okay, so let's see the performance comparison, how it is there with ARM, running everything on ARM versus running on the C7X plus ARM, right? So ARM only we are saying the latency is around 2.04 millisecond and CPU load is around 37%. It is basically CPU bound and limited scalability. If you have the multiple channels running on this A core itself, that will be causing problem, which will not have the enough bandwidth to run any other application, GUI and other things. When we are running on the ARM plus C7, we can see the latency has 6x improvement. It's coming around 0.33 milliseconds, and CPU load reduced to 21%, which is basically around 43%
direction. So, and DSP load is around 7%, which gives the enough room for running anything else on the C7 DSP as well. Right? So that's what we are saying. Basically, this DSP offload mechanism, what we are showing, it transforms system performance from the CPU bound to scalable, reliable, real-time system. Right? The signal chains, what we were showing here, this is not strictly identical, but the result reflects the system-level improvement with DSP offload. Okay, let's go to the current status and plan ahead. So current status is that we have the complete DSP offload architecture available. We have all the library frameworks, the buffer management, zero config data, all this available with ALSA. We have the achieve end-to-end real-time multi-channel processing pipeline, DSP execution on L2S RAM for optimized latency. And the next step is basically we integrate this with the Pipewire, the modern Linux audio stack with GStreamer, right? And the main part is that we want to extend this to DSP plus AI hybrid pipeline, where we run the analytics on the DSP core for feature extraction and inference. Basically, let's take example of your audio conferencing where you want to have the noise suppression, right? At the same time, you want to know where exactly the speaker is present, how many speakers are there, all those kind of things we can do using this framework. So that is the next stage we are going to do. We want to enhance the scalability for higher number of channels, bandwidth, and workloads, improve buffering and scheduling, and add some more information on how to profile tracing and latency measurement tools, etc. Right? Yeah, there are some references which you can refer it, which has all the information. As I said, TI, we focus on open source upstream first, so everything is open source. You can go through these links, references, and get all the information from there. Okay, so little bit on the credits, basically from the Bharat Ramesh from TI C7X DSP team for the DSP side kernel implementation part, then Anup Krishnan from the TI AM620 RTOS team, and obviously the Texas Instrument itself to giving this opportunity, right? For any thing, you can reach me at my email ID is given over here, and our IRC channel is there. That's all for my talk. Please, if you have any questions, let me know.
All right, so we don't have time for questions because of time limitations, but Vishnu would be available throughout the event, and you are also coming to the after-event meetup.
Correct.
Right. So, first of all, like presenting such complex things like in real time, especially with VPN, like in a different system, is a really big deal. So, big round of applause to Vishnu for actually showing us in real time what the values are.
Thank you.
All right, so Okay, everyone, let's get to the next talk by Meera Sundar, who is a software engineer, musician, and newly minted audio engineer. Her talk is titled The Agentic Symphony, Multi-Agent Collaboration for Emergent Musical Composition. Please give a round of applause for Meera.
Thank you. Like Prashant said, I am a newly minted audio programmer here. So this is an experiment, really, and I will explain where this came from. So the question I was trying to answer is, what if music could emerge from conversation? That's obvious, right? I mean, when a band jams or when there's a concert, there is a conversation between the musicians. But what if this happened with just AI or agents, or if a computing process, which several computing processes, which collaborated and had a conversation, and is there any emergence going on? So why am I exploring this idea? So I am a trained South Indian classical violinist, Carnatic music, and while my training helped me with a lot of things, it didn't really directly help me when I had to get into performances, right? So for people who are new to the Carnatic music idiom, typically the concerts are, there is a vocal, a lot of times there's a central vocal performer, and they are accompanied by mostly the violin, and there is a rhythmic, a few rhythmic instruments, or at least one, the mridangam. But so I used to play a lot as an accompanying violinist, and I remember it's as clear as yesterday. The very first time I played a concert, I was super young and super like newbie vibes, basically. So I thought, oh, there would be a rehearsal, I would really nail it. And also I spoke to the main performer, and all they said was, I'm going to sing Raga Latangi. This is all I got from them. So I tried to ask a few more questions, but okay, basically nothing happened, so that's all I had to go with. And it's not like that's the only piece he sang. There were quite a bit. This was just a central piece. But long story short, that bombed. I mean, it was like the worst performance ever from me or from anybody for that matter. But the point there I'm trying to make is, to somebody who's listening from outside, some of these conversations that happen in concerts are, I mean, they all come together pretty seamlessly, and you don't really notice a lot of things, even though we have not rehearsed or any such thing. So it's a lot of it happens on the go. And just to be clear, I've played like more than 300 concerts after that, so I got really good. But there was a learning curve there in how I would have a conversation, how I would respond to a situation where there's a lot of math. They'll just throw some math at you, and you're supposed to respond, and there's a lot of things happening. So after these experiences sort of got me thinking about, what if I had agents, AI agents, if you really want to get into that, do this sort of a conversation, not a Carnatic conversation. I didn't want to right away get into that. Western music, as you know, is more amenable for things like harmony and collaboration and that sort of thing. And there's less to worry about in terms of oscillate gamakas, none of that. So, and not to bring that down, Western is amazing. I'm a trained Western violinist as well. But the point I'm trying to make here is that that's what I've stuck on with, that idiom. So all our pieces will be around that. So that was the backstory of this experiment of mine. So several autonomous agents, each with their own objectives, and listening and responding in real time. So let's move on to the actual, I'll show you a piece. Yeah, that was, I didn't compose, I didn't do anything. I just got the agents to, basically listen to each other and generate this music. One second. Okay, so what you just heard was 4 agents collaborating with each other, which was the harmonic, melodic, rhythmic, and textural. So the slide actually says it all. So chord progressions by the harmonic agent, motifs and melodies, and developing those by the melodic, and then like adjusting the tempo, the patterns, pauses from the rhythmic agent, and intensity and dynamics from the textural agent. So we have these collaborating, and okay. Yeah, okay, this is just to show you the sort of the pipeline of how things execute for each bar of music, right? So the harmonic agent, okay, so basically if you're familiar with AI agents, there is a concept that they speak about called the React framework. This has got nothing to do with React.js. This is reason and act. This is how agents behave is the thesis there. So in this, if you look, the harmonic agent has a read, decide, respond, act, and update the context. The context is super important in this whole thing. So we'll look into that a little bit more. So so we have the harmonic agent reading context, deciding which chord next, responding in case the melody comes back with a bit of a tension, and then generating MIDI for the that particular chord. So, and the melodic agent, what it does is what it does is again read, decide, respond, act, and update. So the primary goal is to decide to whether repeat a motif or vary the motif, and then create tension, resolve the tension based off of the harmonic agent's notes. And okay. And the rhythmic agent here is, again, the same thing, right? Read, decide, respond, act, and update. So speed up, slow down, energy, intensity, setting any patterns, that sort of thing. So that's the rhythmic agent for you. And then you have the textural agent, which basically, again, louder, softer, contrast, supporting, so basically controlling the dynamics. So there is no conductor per se. This is the Agentic Symphony. So this is kind of like the conductor, which is taking care of those finer bits here. And finally, so the communication protocol. So I said the context was super important here. So there is a central musical context which is defined in a Python class like so. So basically, it's the shared musical state that all the agents read from and write to. And these are some of the attributes: current key, chord, tempo, time signature, and a bunch of other things. I will share a link to the repo if you want to take a deeper look into this. Okay, so I'll just show you a progression, how the harmonic agent alone would sound, and then add on one more agent and how that might sound. Yeah, you get the idea. It's basically just chords over chords over chords. Now, let's see if it's a little bit more interesting. Yeah, so those bits, those modulations slightly off the thing was, I found that to be interesting. So, I mean, just to go back to the central theme for a second, so I'm looking at if there's emergence here. Is there emergent behavior, right? So emergence can be very philosophical. I don't want to get into that, but is the overall sum of the parts sounding better than the parts, or does it sound more coherent or more pleasing, or whatever you want to define it, but does it sound like a complete sort of a piece than those individual parts is the thing that we are trying to explore here. This was harmonic and melodic, and then on top of those, let's see if, so by rhythmic agent, I don't have like a very obvious, like a drum beat or anything. It's regulating the rhythm of the entire piece. That's what's happening. Pauses. Yeah. So, and then finally, all agents together. Added a few instruments. Yeah, so the agent thinks that if you use a trumpet, things like intensity or like, it's the energy is amazing or something like that. So that was the reasoning there. But I gave it a bunch of instruments, sound fonts, I think that was called. So it had a palette to choose from. But initially I was just sticking to the piano left and right. Yeah, but one problem, I found with this, they never end a piece like satisfactorily. It's all like up in the air. I'm like, wait, what next? So that's something I need to look at to see if I can fix that. If anyone has any ideas, just let me know also, I'll try it out. But that's all. I'll just let this play so that. Yeah, see, it was like, what? The piece just ended. So, yeah, that was a problem, but yeah, so basically, okay, the next bit, so far there were some rules. I said use C major, these are the chords, you can modulate to these adjacent ones, that sort of thing. It's a bunch of music theory that I threw at it. But I also started playing with a bit of an LLM piece there. So I just used Claude Sonnet 4 and for making some of the melodic decisions. I just found that 30% was a sweet spot because too much of LLMs can also be like number one, latency, number two, cost. Number three, create too much of unstructured thing, too much creativity maybe. So, so this I found was sort of a sweet spot, but it's work in progress. We'll have to go and tune things around a bit, I guess. Yeah, so let me see 1 second. Yeah, so this, to build on top of that, yeah, so Claude would be given a bit of context, what we had in our shared context object, and then it is given a set of options, and then it gives a response like, so transpose, high tension. So based off of that, we try to change that particular note. So I could even show you the prompt right here. Yeah. So my prompt would look like this. So we give it a musical state and give it these options and guidelines, that sort of thing. Yeah. Okay. So. Okay, the central point that we are trying to look at is emergent behavior. So the entire system's behavior that arises from these small agentic interactions, not programmed in a like hard-coded sort of way for any agent. And so we had, so let's listen to a few of these. So call response patterns, whatever I have listed here, I'll let you listen. Yeah, again, bad, not a great ending, but you saw that there were these productive disagreements which were kind that, so which actually gave it a different sort of texture, a bit of a tension, so there were some dramatic arcs going on, right? So I'll quickly play half of each piece. Each one of them is a bit long. Yeah, some of these are starting to sound very similar because I kept my experiment to a limited set of chords, limited scale, key. So the next thing to do would be to expand that palette a bit and make it a little more interesting. So I understand that some of these are sounding very similar. One last one. Yeah, the voice harmony. Yeah, so that's it. Trying to be the system trying to be dramatic there with all those instruments. Yeah. So quickly on the tech implementation. So we have mostly it's a Python with the Mido library for the handling MIDI and fluid synth for MIDI to audio rendering, and then as I said, I use Claude, and that is basically a musical agent is like basically doing listen, decide, and act, which builds on top of the React framework, like I said. One last thing I'll show you is how the LLM. Let's look at how the LLM might. Yeah, so I have a few presets like dramatic and no instruments, that sort of thing. So what we'll do now is. Okay, so we will say preset LLM heavy. I keep it small, bars 16 maybe. Okay, keep it interactive. All right. So you can see the LLM melodic decisions just streaming in. So it talks about the high intensity at measure 7, calls for dramatic effect with contrasting, that sort of thing. Yeah, so it's done, render and play. Yeah. So that's how it, you can tweak things a bit if you wanted more LLM heavy or just pure rules, that sort of thing. Yeah, so my learnings from these, right? So basically multi-agent systems which communicate through shared state is the primary architecture of this. Implicit observation and so balancing their own objectives versus the collective coherence. So, and increasing the amount of memory available to these agents, like how much of the piece does it have context of, is going to give you more coherence across time. And failure is actually good. So somebody spoke, he spoke about it. So yeah, so failure is good. So controlled failure actually creates interesting outcomes. So that's good. And as a musician, I feel that's a great lesson for me to learn. And then music as a test bed is where immediate audible, you can hear the dissonance or you can hear the agents disagreeing if you listen really closely. And so there's a visceral understanding of this idea of emergence. And yeah, like I said, failures are beautiful. So these were some of the things I learned from this project. And future directions, there are people who are working on similar ideas, but from a different point of view. They use reinforcement learning to learn from feedback, and then expanding to, number 2 would be expanding to more musical styles, which jazz and say Indian classical are a bit of a challenge for obvious reasons, but yeah, that's one way to go. And is there a way to introduce a human as part of this? Can I collaborate and compose with it, maybe? One other thing is, as a student, can I get some practice? Can it be like my practice buddy, maybe? Something to explore. And then maybe can be used for live performance systems. These are some of the things I'm considering, but I don't know which way it would go. We'll have to see. So if any of you had more ideas for it, please do reach out to me. I'm on Instagram and Twitter. That is the repo. The repo is there. The code will be pushed right after this talk. I didn't want to jinx it, so I'll make it available in case you want to check it out. The empty repo is available right now. Yeah, thank you so much. Thank you to ADC and Prashant.
Thank you, Meera. We have time for one question. Okay.
I have a pretty basic one. Here. You said the agents are interacting with each other and coming up with stuff. And initially you said there is one person in a Carnatic thing who's leading it. So here was the improvisation based on the chord is fixed and then the stuff is being...
Yeah, valid question. So here, there is no, okay, this is not a mirroring of the Carnatic thing, just to be clear. Here the chord is fixed. So that was the initial iteration, but later there is, if you saw the interaction, there's a bit of a back and forth from the melodic, harmonic to melodic. It adjusts the chords as well because it's a MIDI generation, right? At the end of the day, it's able to go back and forth and change what it's creating for the MIDI. Whereas if I'm performing live, if I sang a note, I sang a note. I can't just go ahead and say Command X, Control Z, and then undo it, right? So that's the difference here. But if it were a live generation, in the sense live music, rather than getting to MIDI and then rendering it, that would be, yeah, no, there has to be somebody who's calling the shots, like you say.
And
does that make sense?
Yeah. And it works the other way around also, like you can figure out the comping based on the lead lines. Like the chords can be generated by this.
Yeah. There is a feedback loop going back and forth. My initial iteration did not have that, but Emergence truly is that feedback loop happening. So that does happen actually. Yeah.
Awesome.
Nice
Thank you
question.
so
Thanks.
Right, that's all the time that we have for the questions. Please meet Meera after this talk and during the networking break. And I hope you're also coming to the after event meetup.
Think
Yes,
so.
yeah. Please ask your questions to Meera, and please a round of applause for Meera. Just 1 second. So, okay, we can resume the live stream. All right, everyone. So, I met Abhinay Khoparji, or as he likes to call himself, just Khoparji. I mean, not just Khoparji. I think 4 years ago. And the only question that I have for him is, how does he travel so much? Like, anytime you ask him where he is, he's in a different city every day. So we somehow managed to get him to give a keynote here. So Abhinay Khoparji is a multidisciplinary creative technologist and instigator of ADCx India, maintaining a creative polyglot practice that merges cinematic direction, live-coded performance, and critical advocacy for a sovereign and open web. Please join me in welcoming Abhinay for his keynote, Patterns of Practice, Translating South Asian Heritage into Algorithmic Logic. Round of applause for Abhinay Khoparji.
Man, that was a grandstanding introduction, but okay. I'm a bit of a monkey though. It doesn't fit any of that grandstanding sort of description. But, so my background is kind of bizarre. I am a mixture of, I don't know what kind of educational thing I come from. What I can say is I play with technology to do creative things. And I'm lately, past 10 years, I've been trying to get people to do the same thing. So my one life is as a filmmaker. I've made 2 feature films. I wasn't the director. I was the technical director and the director of photography, so I was still above the line. The first film was like in 2012. We did a whole bunch of festivals and stuff, eventually got a fairly nice release over theatrical and OTTs and all of that. The second film released in 24, but we were trying to get it out a lot earlier. And my other life, which I have been doing for the past 10 years almost, kind of came out while I was waiting for this film to come out. So my other life was being an artist, a creative computational artist, you would say. So I would put up installations like this one. So this was for Serendipity Arts Festival. So this is the physical version of that. Then I used to help artists realize their own tech-based projects. So this was done for this artist called Nandita Kumar. And this sketches on the left side, those were done in processing. And then this year at Art Fair, this was shown as a sculpture, like a huge sculpture. So this was a thing called Metro Sonata, where people would come up and like just move around, and it would just trigger some sort of sounds from the Delhi metro, and try to create music out of it, sort of a gestural interface, trying to celebrate the idea of the sounds from a metro and, have fun with it. My other life was running this artist collective called Third Thought, which we used to like host these dirty ass parties with like wild music like so a lot of this music would be very loud, very violent sometimes, kind of complex time signatures, essentially electronic music, but with not exactly 4x4 all the time. I mean, just getting interesting with it. There was a time this was called IDM. There was a grandstanding term, like full form of this genre. I like to call it irregular dance music, IDM. Okay, so this other part of my life that started about 10 years back is how I met Prashant as well, is this sort of practice called live coding, which you might have seen at conferences like this where people come and like code, and we perform with this. So there's this person called Alex McLean who was doing the same thing. I was doing the same thing in India as well. We were just not giving it a name. So most of the time, the kind of gigs I would get would be mostly in art galleries where people are just like, this guy is making some noise, I don't know, some people get it, some people don't get it, some sort of agentic systems, whatever. But we were trying to have fun with it, we were doing parties with it. So Alex put together these two words along with his friend Nick Collins, and Algo and Rave, Algo Rave. So we, in 2018, we started doing these events, starting with something called Fat Finger Mayhem. Fat Finger is a phenomena that would happen if you were trying to type and somebody's looking over your shoulder and you're always messing up. I'll show you a demonstration of this a little bit later. So this event happened in May, Fat Finger Mayhem. So we did about 2 versions of this, Fat Finger Mayhem. Eventually we got out and like started doing independent events. So first one in Bangalore, first one like all over the country essentially. This was like a beautiful event in Pune, one of my favorite places to play at because the audience is just, I mean, they let us do anything and still have fun with it. Like in fact, in this picture right at the back, I was playing some very odd time drum and bass essentially. And this person was trying to dance to it. I found it so like beautiful that even though they were not getting the timing, which is what would happen in like a prog rock concert or whatever, right? You're trying to figure out how to headbang, and the time signature keeps changing, but it's still fun. I mean, that's where it is. That's what music needs to surprise us, right? So, been doing these workshops all over the place for this exact thing. I mean, with everyone from like adults to like kids like 10 years old. This is kind of like the first event. This is the person who I started ADCx India with. This person is called Dhanya Pailo, but there is a whole bunch of people who have made ADCx India possible. Some in this video. So lots of different systems. Some people are doing like Max MSP, if you know what that is. Some people are doing Gibber, which is like this beautiful platform that was put together by a person called Charlie Roberts. I mean, These names we can discuss later, proper legends in the scene. Max MSP is a system that I'm guessing a lot of you might be playing around with, trying to prototype things together. This is a person called Akash Sharma, another brilliant live coder, and also he makes these beautiful generative art pieces. He runs his project called Sound Codes. Look him up when you have the time. So this whole Algorithm India journey, I mean, started looking back a little bit of where the heck all of this was coming from. And turns out a lot of the stuff that I play with a system called Tidal Cycles, which we'll discuss again a little later, has its origins in India. So everyone knows of Jamshed Bhabha, right? So he was trying to put together a system to put notation in Hindustani and Carnatic systems. Because for the most part, you guys are more equipped in this, because I did have a very small Hindustani classical education, but I was an idiot 5-year-old who decided that, okay, it was too boring at the time. Even though I had like one of the most legendary masters, he was also a master to Hariprasad Chaurasia, but idiot kid, whatever. Eventually, I did learn drums, and this is what my musical journey kind of continued onwards to. So Jamshed Bhabha was trying to put together a system for notational systems. He met up with this person called Bernard Bell, who was doing this completely different research on intonation of Indian rags. And there was another person called Jim Kippen, who was like every white person of the time before air conditioning, was hanging out in Missouri, and he met up with this tabla player and ended up figuring out a very beautiful project where he would analyze the way, Hindustani music is improvised, right? So these guys would try to figure out what the heck is even happening. How are these guys trying to improvise while having some systems in place? Remember I was talking about that whole filmmaking thing that I was doing? So the last film that I did is actually also improvised. So since that point, my life itself has been improvised. And as you might have been noticing, even this talk is kind of like that. So this is Jim Kippen. This is Afaq Hussain. Jim was kind of learning from Afaq, but also they were collaborating on the system of classifying different kaidas, right? And on the other side, Bernard Bell was trying to do something like this. So this was coming in from something called the Melodic Movement Analyzer, which was, all the Hindustani and Carnatic people, you guys already know what I'm talking about. So this was some research happening in NCPA. There was another bit of work happening in ISTAR in Delhi. And they kind of combined forces. And what came out was essentially trying to classify these rags, trying to do machine learning at that time, back in the 1980s, which is ridiculous, on like an Apple II system. And most of our music tends to be in cycles. So what they decided was, okay, let's try to take it from the Hindustani system where we would divide time further and further, and just do variations on that. So has anyone seen this sort of chart before? Mr. Chomsky, before he was hanging out with the islands, he was making something called the hierarchy of languages. So this kind of system is what inspired these guys into kind of making a hierarchy of dividing time. So first they did this for tabla, and essentially this is like what, I mean, again, you guys are more qualified for this. I'm a script monkey, more of a script monkey in this sort of space. But this is how you would put together a sentence of music, right? Bernard Bell came up with this system called the Bowl processor, which would basically take that grammar, break it down into little words, and break that down into little characters, which you can put together, which I would do a demonstration of this, in this system, and which itself inspired a system called tidal cycles. So Alex McLean, the person I was talking about, who came up with the term algorithm. So you would have a system like this. So Fat Finger Mayhem, let's see if it works. Nope. So tidal cycles itself is put together with there's a system called Super Collider that's running on the side. So now it's running on the side. I'm loading up a whole bunch of samples. At the bottom is tidal cycles, and I would have a simple bass drum. Hopefully there is sound. Is there sound? Okay, great. There is sound. Right? So this now lets me do music or patterns in time, but in a very simple way. So I can do something like, right? Of course, you can do this in any DAW. But then if you're in any other DAW, if you're trying to do this, I've suddenly changed time. And then I can further change time. Right? Now I can do things like Fat Finger Mayhem. Try to do this in a DAW. Now this, sort of a simple system like that, simple language like that, lets me perform different things. Let's say I take up a sample, some sort of a simple pad. Let's say I am gonna change it. Okay, let's just play one, and then we'll see what to do about it. So, okay. Their samples are kind of overlapping on top of each other. Much better. Fat Finger Mayhem again. Sorry about that. And it's essentially that, what we saw with tabla patterns being broken down, right? Of course, you're coming from some sort of a Hindustani system, then you would be, of course, changing the speed of the cycle. So I can do something as simple as, or and put this together in a generative system. Okay. Okay, shut up now. Okay, cool, yeah. So, yeah, this is all I was doing. That's all there is. I was taking cycles, I was dividing cycles, all coming in from a system that was derived from Hindustani styles. And this is that bold processor thing I was talking about. As of now, I've been looking for systems like this for a while. BP3, which is the latest iteration of which believe you me, running on PHP and Csound, and tidal cycles. Literally the only two systems that I've found that let me do this kind of time division without having to do any math on my end. I mean, Csound is great, Superglider is great, but they don't let me, I mean, they do continuous signals very well, but they do not let you divide time as beautifully as this. The cool part about this bold processor system was the BP1 actually ran on an Apple II. And at that time, it could both make a pattern as well as you could give it a pattern and analyze and tell you whether it fits in the qaida or not, right? I still don't know of any systems that do that reliably for Hindustani systems at all. If you do, please do educate me. I would like to learn more. So all of this has kind of inspired, so this is what the tidal cycle system is kind of built on. Back in the day, like I made this, like a version of this presentation a long time back when I was using the Atom editor. Of course, it doesn't exist anymore. So I was using Vim right now. So whatever editor you are running on, you can. Tidal cycles is built on Haskell. So I was running the Haskell part, at the bottom, my Vim editor at the top, SuperCollider doing the sound generation on the side. And SuperCollider is just doing sound generation. I could stick in anything. So if you have any other music making or sound making device, synth, whatever that. I had mentioned, I had asked a question earlier today about why not OSC. So this is the example of OSC integration running tightly. Because tidal cycles is essentially just sending events in time. And the events in time are getting received by a supercollider, and it's doing synthesis on the fly. So right now I only showed you examples of doing this with samples, but of course you can do synthesis with supercollider, with Csound, or whatever else system. All of this also got, I mean, I've been trying to do workshops on tidal cycles for a long, long time. Most of the time, because of just Haskell's difficulty in trying to get it installed in places and all of that, most of the time their workshops would be more tidal install parties rather than actual workshops. So, because once you get started with it, the grammar is so easy to pick up, right? And you can even start translating things like, I did something idiotic, of course. So I took, does anyone know what the Amen break is? Right? Okay. So I took an Amen break, cut it up into pieces. So a simple Amen break is like, yeah? So this is one sample from the Aman break. This is another sample. So I sat there, classified each of the sections of our Aman break into tabla bowls. So if you want, on the Tidal Cycles forum, you can find this post. It's still one of the, if you try to look for bowls, this would turn up first thing. So I can literally just start doing some tabla players here. Can you tell me a nice pattern? Dha dha. Let's see if this works. Then next cycle, dha dha dinna. And then I can be at an event and just start doing my pads thingy again. I don't know. So this is basically a folder full of samples that I have. The same language just that you guys know, just translated here, right? And you can go and mess around with this. And all that it required me to do is put in this tiny bit of Haskell code, which is just stupid, I was thinking. This bowl processor thing was interestingly, it had another collaborator, which I found out about it much, much later, is this person called Srikumar Subramanian, who actually has put together a platform which you guys might already be using, Patantara. So he basically was one of Bernard Bell's juniors, and he helped him put together BP2 actually, not BP1. And actually, Meera's repository is a pretty cool resource that you should look at. Awesome Carnatic music, which has a link to Parantara. So if you want to go check that out, please do. So he put together a couple of very nice tools. One is what I found pretty cool for people who are trying to learn the tabla or just languages of Hindustani music. So something like a metronome like this. You get it. The cool part about Patantara is it also lets you change time cycles for melodic pieces. And what it'll do is it'll figure out how much, so when a Hindustani or Carnatic performer plays, if they're changing the time cycle, okay, you guys have done, you use DAWs, you have done automation. And if you've done any automation, I don't have a demonstration of this, but if you've done any automation, if you squeeze the automation in a smaller time cycle, you would find a bunch of the things kind of get moved around too fast. Stuff that we do not even notice. So it figures out how do actual performers change the piece where they would overshoot a note, where they would skip out certain bends in the gamak and essentially be able to reproduce it in a more realistic manner, right? So I would say take a look of this. At the moment, I just wanted you to introduce you guys to some of these systems. I've been trying to put together things around this for a while. If you can help me out, please contact me, because I've been waiting to see systems like this in traditional DAWs, traditional music making software, because, I mean, we need to get this whole language back in our vocabulary. Yeah, so that's me. There's algorithmindia.in. That's my website. I'm on socials with my surname. There's not much more to add from my side. So thank you so much.
Amazing. I think we absolutely enjoyed that performance. Let's take some questions.
Hi, my name is Kshitij, and I absolutely loved the demonstration and the whole idea about this study pattern. Like I was completely unaware, and I've been studying for a while. So I have something that I would like to talk to you after. But for the question is like the tidal cycle you used. Can it also be done with strudel?
Yes, of course. Yeah. So strudel is. I actually did put strudel aside. I mean, strudel and tidal are the same thing essentially. Yeah. Strudel is a port of tidal cycles. What the great part is, it works in JavaScript, so it works in the browser. So you can do the same exact thing. So what I was doing here, I don't know. So right now I was trying to use samples. Yeah. So it needs internet for that to work. Beautiful part is we talked about Csound earlier today. Csound works inside strudel. So you can literally put together a Csound patch. So all of those same things work again. Yeah. So you can check out. Have you seen strudel? Csound in strudel?
Yeah.
Yeah. Because Stephen E has put together a very nice collection of synths right here. Yeah.
Thank you. Yeah, this is interesting.
So I did put together a bunch of sketches around basically just breaking down Hindustani tals and sticking it into strudel and making like beats from that. Yeah.
This is very cool. Probably the next step I'm going to try for the electronic.
For sure. I mean, one of the first algorithms that we did, I translated the same thing on Dole. So, I mean, I like to monkey about with these things a lot. There's this another live coder called Tiger Babu who plays on Sonic Pi. He and I are infamous for doing like taking Bollywood songs and like deconstructing them. We'll take like Urvashi, putting like a bass mix on it with just live coding systems. Put in like a dhol in there with like some dubstep bass or whatever. Yeah.
All right. Any other questions? Yes.
So in the last 10 years, you mentioned you have been, growing algorithm in India. I have seen live code happen in different parts of the world. How do you think the scene has grown in India? And because, okay, so like I got introduced to live coding because of you in 2019. I attended an event at Cuckoo Club and it like just hooked me in right then. And I've been live coding since. But like, I don't know how much of a scene is there. What are we doing to build it? Because I do enjoy a lot of live code gigs, but somehow I think I'm an outlier maybe to do that. But yeah, just curious to know your thoughts on, how is the scene growing? What are the big bottlenecks? And yeah.
So I mean, scene is growing. We did add another city last year. We did Hyderabad. And I have been doing workshops like crazy. For the past 5 months, I've been just traveling. As Prashant was talking about, that he always finds me in a new city. So yeah, I would say post-pandemic, there was a spike on a lot of interest in these kind of things because also people suddenly found time to play around with art, right? But right after that, everyone got busy with work because everyone was crunched. So we have lost a little bit here. Hopefully 26 is going to be better. We are putting together things. There is now a Bangalore chapter, like their own local chapter called Live Code BLR. So, I mean, if you're here, do check it out. Otherwise, we've been doing gigs on and off, yes. We did put together an album of fully live coded music with generative visuals, which is there on the website. It's also there on Bandcamp, so if you want, you can look it up. Yep.
Awesome. Any other questions, ideas? Okay, I think I can ask a few things. So
Sure.
I think I also resonate with that whole concept that in general, some things don't scale up if they don't reach the right people. Or sometimes when somebody who has never used Strudel or tidal cycles, but they see it happen and they then realize, this is what I want to try. So any thoughts on making that more visible? I understand that you're doing shows, you're teaching in so many universities and everything.
I mean, it's not just me. I mean, other people have been doing this as well. I think that the whole LLM scene has kind of killed it a little bit because for the longest time we were trying to tell everyone, oh, it's brilliant to learn to code. And then the CEOs are now telling people that, oh, coding is solved. So it's definitely not solved, as we have realized by now. But I mean, hopefully that's why I'm thinking 26 should be better. Yes.
I think it's a good note to conclude the keynote. So round of applause for Abhinay Koparji. How's everything going so far, everyone? Are you all enjoying the event so far? All good? All interesting talks? Okay, we have the last batch of talks remaining, and they continue to stay interesting. The first one starts with a topic about game audio, an industry that is still in its very early stage in India, like everything in music tech, but a niche is game audio. So if any of you have not started in game audio, I think this talk is going to help you a lot. The talk is by Nikhil Dahake, who is a game developer and audio engineer with experience in gameplay programming, performance optimization, and sound design, focused on creating smooth, fun, and immersive gaming experience. Please join me in welcoming Nikhil for his talk, From DAW to Game Engine, Unfiltered Creativity.
Hello, thank you. Thank you, Prashant. So let's start. Hello and welcome to my talk From DAW to Game Engine, Unfiltered Creativity. In this session, we'll be sharing you about my journey from creating sound in a DAW to building game audio systems. And by the end of this talk, I hope to share with you how audio workflows look in a game. To make it easier, let me break down into the steps. First step, basic sound integration and playback. Second is adding dynamic and immersive audio behavior. And third is audio optimization. Before diving into the steps, a quick introduction. I am Nikhil Dahake. I have around 8 years of experience in the field of audio, and I am a FTI sound graduate. I have worked as a sound editor for various films and web series, where I used to do track laying, sound designing, or any other audio post-production works. And for the last 5 years, I am developing game and designing sounds for them. I am currently working at Super Gaming as a game developer. About Super Gaming, 100-people gaming studio based in Pune, India. And for the last 10 years, we are creating real-time multiplayer games for mobile. So our most ambitious project is Indus BRX, a 60-player battle royale shooter game for Android and iOS. And yeah, it's available in India, so you can download it from Play Store. So inside Indus BRX, we are using Unity as a game engine and its built-in audio system. And on the top of it, we have created our own tools and our own audio systems, which we call Audiograph and Audio Copilot. With a basic introduction, let's start with discussing audio in DAW versus audio in game engine. So when I was working in a film, my job is to find the sound elements inside the frame, design them, and make that scene very aesthetically impactful. And since Shriji sir is there, he might have a good idea of sound design. So yeah, and films, audio follows a fixed timeline, and it is a non-interactive media, whereas games is an interactive media where audio is triggered by gameplay events. We have to design sounds for each feature, integrate them into the engine, and have to set up the playbacks. With this, let's start with step 1, basic sound integration and playback. So design your audio clip in a DAW. You can use any DAW. So I am using Avid Pro Tools. Integrate them into the engine. Set up the audio parameters like volume, mixers, channels. And this is a simple way to play audio in a game engine. I am showing you Unity's play one shot function, where you have to pass the audio, and audio will be triggered as per your requirement. Now let's take a simple example, which is player jump audio system, to understand how events and playback works together. So it has 2 types of events inside this system. First is jump start, and second is jump end. So after integrating sounds for this, it sounds like this inside the engine. Okay. You might be thinking why I'm showing you such a basic example, but as a sound designer, I might create a single clip for whole animation. But in future, if there is some decisions key, if we have to change the animation speed or any height speed, so there may be chances of getting that audio out of sync. So as an audio designer, I have to take a call that we have to create separate audios for separate events. With this, let's recap step 1. Become familiar with game engine, mostly on audio, playback, and integration part, and understand the game system and events before diving into sound design. We have completed step 1, basic sound integration and playback. Now let's start with step 2, adding dynamic and immersive audio behavior, which is one of my favorite, and I think you will also like this. So what is dynamic audio in games? Sound that changes in real time based on game states. And what is immersive audio in games? Sound that makes player feel like they are inside the game. And any guesses from audience? Why is dynamic and immersive audio important in a game? Any wild guesses? Coffee अगर नहीं पिए क्या आप लोग? Yeah? Okay, so for me, yeah, it's my point actually. So for me, it's a gameplay feel, like if player running on different surfaces like metal, sand, water. So different surfaces has different footstep sound. And the other one was your point, gameplay feedback. Ki, if player health is low, so as a sound designer, I might trigger a heartbeat sound or any warning sound to get so this sound will instantly notify the player that your health is low and you have to recharge yourself. Let's take a real-time example, which is enemy footsteps. So in Battle Royale shooting game, enemy footsteps plays an important role. And with the help of that sound, player easily notice or judge the position of that enemy. And on the basis of that, he decide whether to take fight or defend. So we already have a 3D audio working inside the game, like the left-right panning and the distance-based volume attenuation. Like if enemy is far away from me, that distance will be less. And if it's nearby me, it will be louder. But the problem here was elevation. So we don't have any different audio treatment if enemy is above me, and same for below. And again, we are creating a game for low-end devices. So we can't use any heavy processing plugin like HRTF or any heavy plugins to adjust this thing. So we are using equalizer, which is our favorite plugin. So if enemy is above player, we are boosting low frequencies to get the thumpiness feel of that sound. And if it's below me, we are adding a telephonic effect to it. Let's see how it sounds in the engine. So these kinds of techniques help in improving the gameplay. Let's take another example, which is gun firing sound. So we are having two types of weapons inside Indus BRX. First one is single fire. So single fire is just one click, one sound. We are pressing the trigger and sound will be triggered. Let's see the example of sniper for this. How was it sounding, by the way? Acha. Energy is very low, by the way, promise. Fine. The other one is automatic fire. So for automatic fire, fire rate plays an important role. And fire rate gives a behavior to the weapons. So let me quickly show you the low fire rate and high fire rate. And the high fire rate.
Reloading.
Did you notice the difference, like why fire rate is important? And while designing such kind of sounds, fire rate should be considered. So in order to enhance our gunfire sound, so we wanted to add a weightage to that sound. So at the end of each fire cycle, we are triggering reverb tail and shell drop SFX. Let's see how it sounds in the game.
Reloading.
It gives the overall feel. Let's take interior and exterior audio behavior, which is an environmental-based example. We wanted a different audio treatment when player is firing inside any room or any building. So which is the plugin, like in this case, which plugin should I use? It's one of the favorite plugin. Quickly. Reverb. Yeah, reverb is the correct answer. But the tricky part here is detecting the interior. So let me show you how we did this. So we are simply checking if there is any roof above the player. And if there is any roof above the player, we are enabling the reverb to that sounds. Let's see how it sounds. Let's take other example, which is Rails audio system. So Rails are very cool feature in a game where a player uses it to quickly change from one position to another. So let's discuss sounds and events for this. Okay, nice. So first one is play one shot. Let's discuss the events for this. We have start jump, speed boost, braking, and rotation. Like we have a different sounds for these categories. And in the looping section, we are having, so by the way, looping is that audio which we are like playing it in multiple times for a continuous activity. So this is a high speed, like you can see it's a continuous activity. So we are using the same audio clip multiple times. So this is high speed, and this is low speed. And again, it's a very complex system with lot of events inside the game. Let me show you the audio video for this, how it sounds. Let's take one last example, which is player dive audio. So it's a sequence in our game when player jumps from a flight to battleground to start fight. Let's study the event on SFX for this. So we have three types of events inside this. The first one is dive start, where we are triggering the jet loop SFX and wind loop SFX. And during dive, we are controlling the pitch and volume of the jet. Like if player speed is high, we are boosting pitch and volume of that, and vice versa for the wind. And at last, we have the landing impact, where we are stopping all audio and triggering the impact SFX. Let's see the audio video for this. So let's recap step 2. Immersive and dynamic audio is important for gameplay feel and feedback. And audio behavior must change with respect to environment, like which we have seen in the interior and exterior audio behavior of the weapons. And the last one is understanding gameplay parameters helps in modulating the sounds, which we have seen in the last example, where we are using the speed to control pitch and volume. With this, we have completed step 2, adding dynamic and immersive audio behavior. So in my studio, I was very happy, like all audios are there inside the completed the audios, and I was ahead of my deadline, and I was very happy. All audio levels are sorted inside the game. But one of my bad friend come to me and tells me there is an issue with the game, which is a performance issue. And since we are creating the games for low-end devices, let me break this down for you. What were the issues? So game's build size is huge, so players are not downloading our build. Game is crashing consistently, and game is lagging. Like there is a lot of FPS drop, stutter, and the heating issues inside the game. With this, I welcome you to the world of audio optimization. It's very hard actually. So first one, let's start with reducing build size. So in our first build, around 200 MB was the total size of audio inside the total build. And we have reduced it to 45 MB. Let me show you how we did this. Simple. Convert stereo to mono. Like you can take any UI sounds or any tertiary sound, which is not important for gameplay, just convert it to mono. For similar audios, you can lower the sample rate and use correct audio format like .oggs, .flag. They are very lighter in size. And trim unnecessary audio length, like avoid long fade outs in a game. Don't keep any unnecessary information in the audio clip, and keep that clip tight and cut to cut. And this is a very helpful tool, and my favorite tool, by the way. It's a memory profiler where you can individually check the size of audio in a game, or maybe size of images, or maybe size of scripts. I'm showing you Unity's memory profiler. It will show you something like this, total size of audio. With this, we have reduced build size. I think अब appraisal मिलेगा मेरे को. ठीक है. Why do games crash? So let's study why do games crash. Again, this is a low-end device of 4 GB RAM. Some amount is consumed by system reserved. When we start games, some amount is consumed by game models, like 3D models of the game. And you can see that's filling in the below side. Some amount is consumed by images of the game. And some amount is consumed by animation and VFX. And you can see it may be crossed the limit of that RAM. And when audio loads, limit is exceeded, and your game will crash. Happy birthday. ठीक है. So let's solve this with the help of reducing RAM usage. So in terms of audio, there is something called load and unload audio technique. This is our main menu, and again you can see it's a 4 GB RAM. Some amount is consumed by system. Some amount is consumed by the menu, the graphics, the VFX, the character, all over that thing. And you can see below 20 MB is consumed by the music, which is background music for that menu. And when player enters into the scene or any game mode or any gameplay, we don't want that main menu music to be taken forward. Instead, we can simply unload that audio. There are a lot of techniques to do this. You can refer the documentation also for this. So yeah, we have to unload the audio. And with this, we have optimized the RAM. Now let's study why do games lag. Multiple game processes like VFXs, SFXs, and a lot of complex calculations running simultaneously, it will lead to high CPU spike. And due to this, your game start lagging, device heating issues are there inside the game, and stuttering issue. To solve this, we have to reduce CPU usage. You can minimize the DSP effects like reverb, compressor, EQ, because it's very expensive, so don't misuse this. You can use something called distance-based audio removing. Let me explain you what is this. If you can see far away from the player, there is some action going on. But that sounds are not audible to me, like audible to player. But in the background, they are playing in the background. You can see there are a lot of audio sources playing, which is firing, maybe bullet surface impacts, maybe footsteps. And it's unnecessary taking up the CPU. And by the way, this is an audio profiler. Tool. So you can use something called distance-based audio removing. So you have to form a radius, and after that radius, that audio will be bypassed. With this, I think मेरा appraisal हो गया उसके बाद. फिर we have optimized the audio assets through reduced build size, use load and unload audio techniques to optimize RAM, and keep your audio playback efficient to optimize CPU. With this, we have reduced build size, reduced RAM usage, and reduced CPU usage. We have completed all the steps. And let's takeaways. So if you are creating any games for future, keep these points in mind for audio kind of thing. Game audio is not just sound, it's a core part of player experience. Sound around knowledge combined with engine expertise creates immersive soundscape. And optimized audio contributes to smoother and more efficient gameplay. And most importantly, remember to have fun while working. With this, thank you for listening. Questions? If Prashant will allow me to take questions.
I am not time. So time is allowing though, we have some time. So yeah, let's take some questions. I have like one, okay.
Hi, thank you for the talk.
Thank you.
Do you work with things like being aware of the actual space and set reverb times, like understanding the dimensions of the room and things like that? Is that something you
Sorry,
do?
sorry, not understand.
So for example, when you walk into a room, when
Huh.
a character walks into a room in a
Yeah,
game,
yeah.
then like, so this room is very specific because it has specific dimensions, so its reverb times and decay times and all
Yeah,
that are
yeah, yeah.
specific, and you go to a smaller room. So do you program these in a game?
Yeah, we have different systems for that. Like we have different presets for this, and we are doing that.
Any other, okay.
Lovely talk.
Hi.
Love the bit of humor as well.
Thank you.
How do you account for audio fatigue, particularly, for example, with SFX? Because what happens sometimes is that if you use, you usually don't use the same one shot anyways.
Yeah.
So you have a bunch of one shots. But in the interest of optimization, you tend to try to keep 3 to 4 one shots, right?
Yeah.
So, but when in a situation you have a lots of gunshots, for example,
Right.
That leads to audio fatigue as well. How do you optimize for something?
There are a lot of techniques for this, but more specifically, I have used something ducking or sidechaining, you can say, inside the thing. We have did this, and since it's a battle royale shooting game, we have to decide ki sound should not cause the gameplay, and so only that specific sound should be triggered inside the gameplay. So there are a lot of techniques. I will tell you after this talk.
Okay, we have one more question, one last question.
Hi, my question is about the background music that we didn't talk about in this.
Yeah, yeah.
So when, like for the example, menus have background music, and so do you like take part in composing that background music as well, or you take care of the sound design part? And how does the memory optimization for the background score plays a role in the optimization process? And like, do you reduce the sample rate for that as well, or because background music has to be very vibrant and clear.
Yeah.
So I'm just curious about the optimization part of that.
So we have compromised a lot of SFX and keep that BGM to dot wave to have that clarity, and multiple audios with the shorter lengths like clips.
And is it like composed?
It's composed. It's composed. It's a baked file, complete file.
All right, so there is also the Game Audio India thing that we try to run. If you look for gameaudio.in, you will get to know that we are trying to build a community in India where people can share information, like on a very casual basis, every Sunday meet on a Discord server and just have a conversation. So you're welcome to check that out. And again, thank you so much, Milap, for educating the audience about Game Audio.
Thank you.
Applause, please.
Thank you.
Awesome. So the next talk is a really interesting one. I've been looking forward to it. It's by Calvin McCormick, who is an MA student at the Center of Computer Research in Music and Acoustics at Stanford University. His research interests include accessible musical interfaces, auditory perception, and spatial audio. Calvin will be giving a talk on building smartphone instruments from commodity hardware, HID controllers, embedded audio, and modular design. Please give a round of applause for Calvin.
Hello. Hear me? Can you hear me? Good? Hi. My name's Calvin. I'm from CARMA, the Center for Computer Research in Music and Acoustics at Stanford. And yeah, today I'll be talking about building smartphone instruments with commodity hardware. And yeah, so I've actually lived here in India on and off since around 2018, except for COVID when I wasn't allowed in. I first came here to work with a nonprofit in Dehradun, and we established a music program and a recording studio there, and it went really well, except there was kind of this glaring issue that many of the women there had disabilities that made it really difficult for them to play a lot of the kind of conventional instruments that had been donated. So in 2022, I received a grant to come back, and I was working with JNU in Delhi to kind of build custom accessible instruments for people with disabilities, focusing on resource-constrained environments and sourcing and manufacturing locally. And this worked really well. You can see there was kind of this hand sensor with a lot of different multi-sensors and capacitive touch, and there was like a musical pillow. And those all worked well, but there was kind of a new problem where all of these interfaces were very kind of customized. There was only one of them. They're kind of Arduino-based, and if one wire came out, I wasn't there to fix it. You know, very, very, very delicate. So this lack of scalability really hampers overall kind of collaborative development and pedagogy. And this isn't a problem just for me. It turns out there was a study at the NIME conference about other NIME interfaces that the vast majority of them had only been played maximum of like 3 times ever live. So there's like all these really great instruments and interfaces in the world that are kind of very specialized, very customized, and never really make it out of a white paper. This past summer, I came back with a grant from Stanford to kind of explore how to solve this problem. And the solution that we came up with was to take advantage of what people already have or can realistically obtain, which in this case was Android phones and generic game controllers. And GameCADs and other HID controllers easily sync with phones over Bluetooth, and it's easy to develop and distribute for these kind of ubiquitous platforms and adjust them for different use cases. For most of the people I was working with in kind of rural Uttarakhand, and statistically for most people on Earth, mobile phones are like a household's sole computing platform, and among these users, this is overwhelmingly Android phones. So controllers, as you can see here, well, controllers are really great. As game controllers are really great for music. They're really well engineered, they're very durable, they're replaceable, they're ergonomic, and they have low latency over Bluetooth. And crucially for this, they're available pretty much anywhere on Earth. You can see I've collected these kind of maps of very remote places where you can apparently buy a PS5 controller. And also there's all sorts of kind of generic game controller offerings which are much cheaper but have kind of almost the same geometry as the name brand ones, which is important because there's been a lot of great work in the gaming community to develop accessible controller augmentations, which you can 3D print for a variety of different physical limitations and gaming use cases. And these translate really well for creating digital music and art. Sony and Xbox have created their own kind of accessible controller versions. However, they're kind of still pretty niche and hard to find, and they're, I think, $200, like 18,000 rupees or so. And so for our project, I was able to find a 3D printing service in Dehradun. And just looking at Google Maps, you can find a similar service in most tier 2 Indian cities. There's actually one on this road, like a kilometer that way. So it's really easy to do this for people who don't have 3D printers. And you can see here some of the controller augmentations that we had made. Some of them I had made, and some of them, they're kind of these vast repositories of 3D printing repositories where people have posted different augmentations for different disabilities, different use cases, different games. And then people kind of tweak those for kind of even more specialized uses, and you can take them yourselves and modify them further in CAD software. So there's a really interesting one in the bottom right corner where it's an attachment that lets you push all of the buttons on the PS5 controller all from the left hand, and it goes on the table, and then you can move the joysticks, and you have full functionality over the controller all with one hand. So basically the architecture we came up with was that on the one hand you have, in this case, mostly gamepads, but basically any sort of input source you could have, gamepads, HIDs like trackball mice or keyboards. We didn't use them here, but also you could use the camera, you could use the accelerometer, you can use the touchscreen, anything, any input source from for the smartphone. And then that all goes to kind of an app layer, which does the configuration of, you have all these different import sources, how do you want to scale them, and how do you want to route them to different parts of your audio and your visuals. And then you can have it create JSON presets to save it for different users, different configurations, different styles of music, and then also network functionality, so you can communicate with other phones that are running this over OSC. And then all of this goes to power either the DSP engine and generally at least some sort of GUI, or maybe some more kind of advanced audio visuals, depending on what you want to do with it. So yeah, this was from our deployment this past summer. It was at an NGO just north of Dehradun called CED Society. And the Android app was made with Kotlin, which is like a native Android language, with libpd as the audio engine. libpd is the an embedded form of pure data, which you can put into Android and iOS apps. We purchased a generic PlayStation-style gamepad controller for 1,500 rupees nearby, and we hired a local 3D printing service to print a number of accessible controller augmentations for a total of 2,100 rupees. And we used the phones, Android phones that were already owned by the nonprofit center. And so we printed several different augmentations in the form of like grips and the one-handed one. So you can imagine that if you were printing just one, you could do this whole system for around 2,500, 3,000 rupees total. And I was able to configure the app as essentially a Bollywood and Nepali pop remixer, which unfortunately means I can't share the videos from that here because it was all copyrighted songs. But you can imagine that each of the 4 directions on the thumbsticks would be the kind of wet-dry for different effects that they could configure and choose. There were like DJ scratching and LFOs and flangers, and then the buttons were mapped to either transport functions or sample triggers. And all of this could be kind of customized, and they could choose their own samples, and they could kind of, depending on their specific disability, we could map it in a way that worked best for them and the way they wanted to play with the song they chose. So now I'll talk just a little bit about some of the audio side of things. So in this project, the audio engine was implemented with libpd, as I mentioned, which is a library to embed pure data into Android and iOS apps. Pure data, as I'm sure many of you know, is a visual programming language. It's basically an open source version of Max MSP. And you have the app side, which is on the right, written in Kotlin. And that does all the routing configuration. And it basically, it's kind of like OSC in that it routes it to different addresses that the pure data patch then receives with each of the inlets. So then you can map either bangs or like with button presses or different floats from the the joysticks and other interactive devices on the controller. So you can map those, and you have a drop-down menu where you can select and customize each one of those and then save them as a preset. And you can also, on the bottom right, you can also set it to integrate with other devices over OSC. And then you can have the pure data patch, if you want, print back into the Kotlin app for visual feedback or for other functionalities, depending on what you want to do. This is really powerful because you can have kind of the app, you can have the configuration and the mapping on one side, and then you can kind of swap in and out the pure data patches. If you want for a different song, a different kind of musical, whatever you're doing, you can have that. It's very modular in that way. There's a few caveats. It's kind of a blessing and a curse that it is very modular, that you can kind of swap in and out these patches in pure data. On the other hand, it's a bit clunky, and you keep having to have things talk back and forth to each other. The other problem is that you can only use the standard vanilla version of pure data, which limits a lot of functionality. And also in my case, where we may want this to be something that, I know vibe coding is a controversial subject, but in this case, you might want non-expert users to be able to customize the app and use it as they see fit. So in this case, pure data and all graphical. I did have Claude make a Max MSP patch the other day that worked, which was shocking. But generally, LLMs are not great at making visual programming languages. So that's a bit of a drawback for many people. So another option, at Stanford, we do a lot of work with the audio-focused programming language called Chuck. And actually, I found there was a Tunity, someone did a presentation on this at ADC 19. So Chuck is a programming language developed by Professor Go Wang, who is at Karma, and he leads the Chuck development groups. And one of these projects is called Tunity, which is a way to embed Chuck into Unity projects, and then you can export it from Unity cross-platform. And using Tunity, you can combine the really advanced graphics and capabilities of Unity with this now very powerful audio tools. They're very well integrated. And it works somewhat similar to libpd, where you have the Chuck files on one side and you have the C# files for Unity on the other side, and you kind of have to have them talk back and forth. But then again, that is also kind of valuable, where you can mix and match and have different versions of the audio side or the app side without kind of conflicting with the other. But compared to libpd and Kotlin, there's a much deeper integration in Unity, where you have the game objects and a lot of other things that really bring them together. And the reason I didn't use this, Unity had kind of become a bit broken in that Android had updated something and then it no longer built for some very small, low-level Android reason. But we repaired that a couple months ago, so it's up and running now, and it works really great. The only kind of drawbacks I would say for that are that it's kind of overkill if you just need a simple GUI and a simple configuration menu. It's a bit heavy. It imports all these libraries, and if you're working with underpowered Android phones, this might not be the best option. There's also the Unity licensing to consider if you're working on commercial projects. And yeah, when I had submitted this talk, it was going to end at that. But in the past, very recently, there's been this kind of new development. So first of all, a colleague of mine, Andrew Ade, has been developing a graphics library for Chuck called Chuggle. And with Chuggle, you can build entire 2D and 3D applications that are integrated with Chuck all in one file. And it's really powerful. The only kind of drawback was that there was no way to export this off the laptop. You had to run it from the command line. But very recently, like 3 weeks ago, another colleague on the Chuck development team, Ben Huang, has taken this a step further and now ported Chuggle to run in the browser, including on mobile devices and including with game controllers and external HIDs. It's not going to be as integrated or as powerful as a native app or a Unity app, but this really offers a ton of flexibility and scalability in that you can just distribute these kind of audio-visual apps cross-platform just by providing someone with a URL. It's really easy to update. It's free. It's open source. There's also there's a WebChuck and a WebChuggle IDE that's also now built in the browser, and you can sandbox and try out all these things. Yeah, it's still really new. It should be released on GitHub quite soon, but I think you can still try it out. The documentation is up, I believe. But it really just opens a lot of doors in terms of be able to just hand someone a URL and they have a whole audio-visual app. To demonstrate this, here's kind of a 3D version of iTabla Pro I made. So it's pretty basic. You can just mainly just looking at like the visuals, but you can go around and you can select the different complexities of each of the beats, and then you can see what happened. It's a really powerful 3D environment, especially to just be running on a browser app. And yeah, so in conclusion, more than likely, most of you will not have the same use case where you'll be wanting to develop these kind of accessible instruments for remote communities. But whether you're working in industry or research or the arts, this kind of modular framework and taking advantage of what people have and having this kind of mix and match capability where people can configure different parts of it to suit their needs is really powerful, and it's a great way to make shareable and adaptable mobile-based instruments for a variety of use cases. And as I mentioned, the world is full of amazing custom digital instruments. I've made a few, and that just never evolve or kind of have more than one user because they're these unique one-of-a-type prototypes. To leverage commodity hardware in this way, like smartphones and game controllers, along with the sort of modular customizable software, allows for instruments that are really accessible, affordable, and have a much higher chance of widespread adoption. And I might have too many QR codes, so I'm sorry. I realize it might be hard to scan all these, but please talk to me after if you have any questions about this. Thank you.
Okay, first thing that I want to say is that if not for this talk, we wouldn't have gotten to know that all this was happening in India. At least I did not know that it's been happening since for a long time, so thank you for sharing all that. Any questions? We have a lot of time for questions. You can take some.
Not so much a question as a point that I thought I'd share with everyone. You mentioned that you used Claude to build a Max MSP patch and you weren't so happy with it, or?
Oh, no, well, before it would, kind of make them without me asking. If I was working on something else that would connect to a Max patch, it would give me one, and then it would tell you to paste it, or it just wouldn't work at all. I was amazed that it made one that it still didn't work perfectly, but it made one that was competent a couple weeks ago, and that is a big step. Yeah, that is, it's still not great, but it's getting there.
I actually had the opposite experience. So I found that Claude so underneath the Max patch, even though you mentioned it's graphical, it actually uses that XML format, and it's still only text because this connects to this and stuff. I found that Codex, like OpenAI's one, actually did an incredible job. I've just been using that now, Codex, to build the Max patches, and it's been awesome. So I thought I'd share my experience with it.
Oh, if that's the case, that's great for this, if people can kind of build their own pure data patches with this. I don't use Max so much these days. and haven't tried. But that's, yeah, last I tried, it was kind of a disaster. It would confidently hand me something that like just wouldn't open.
Okay, we have one more question here.
Is there any potential you think for kind of expanding this use case in terms of, say, for example, mastering or mixing workflows? So thinking of the controller as some kind of an extension to a fader or something of that kind.
Yeah, absolutely. I mean, underneath in the, I think I showed it a little. I mean, you can only see a snippet here, but underneath I basically took all these different effects that people have made in pure data, encapsulated effects objects that people have made in pure data over the years and just wired it up to that. So you could easily take it to these were kind of fun effects like chorus and flanger, but you could easily take that for more, yeah, you could easily use it for more filters and mixing tools. And mastering, I mean, it'd be hard to like hear it. That would be like a different challenge, but you certainly could, yeah.
Right, we have one question on the back.
Hello. Thanks for your talk. I honestly feel the same way about using microcontrollers to build instruments. Like if a wire comes off and there's nobody to repair it, it just goes away. But do you think there's a trade-off when we're using something like a PS5 controller, because there's only so many sensors like buttons and joysticks you have on it versus the amount of sensors that you can plug into a microcontroller? Yeah, is there a trade-off?
Yeah, that's also kind of another blessing and curse. The official 8,000 rupee like name brand PS5 controller has all these other bells and whistles. In fact, if you plug it into an Android phone and like on this part here, it turns into a touchpad mouse. And there's also a gyroscope, and there's like these adaptive triggers that can feel like a bow, like it adds pressure to it, and there's haptics, and there's all these cool things, but it's very hard to, and most libraries are just set to the kind of very vanilla stock HID controller gamepad that is very limited and doesn't take advantage of all these kind of bells and whistles. Max did make an object that lets you use a lot of these. And it's actually a 2-point touchpad, so you can have 2 fingers on it and it tracks both of them. But getting those to work on other platforms I've found to be very difficult, and you have to like parse a lot of Bluetooth, and it's quite unpleasant. So yeah, there are actually a lot of other features that I would love to take advantage of, and that is an area of further development. On the generic side, that is a challenge. That, I mean, if you want to play a scale, I mean, you can see you only have like maybe 10, 12, 14 buttons. So that's a bit challenging. So in that sense, yeah, you're kind of there. That is kind of a creative. You can think of it as a creative constraint. But I really like that you can. There is really a great community of these 3D printable augmentations that you can kind of stick onto them and turn it into something else. There's one that's like a steering wheel. There's some joysticks, and there's a lot of fun things you can do with that. And you can also, another option would be you can, on most phones, you should be able to attach more than one. And you can also wire them is another option if Bluetooth is a problem. Yeah, I hope that. So yeah, it is a trade-off, but yeah, there's, for the cost, I think you get a lot out of it.
Right, any other questions?
I think the 12 buttons give you an octave, and that's more than enough for working with compositions.
Right, but you might want to like jump up a third. Yeah, like it's not.
So then you have a second controller.
Yeah, you're still. I mean, it's not a 2-octave keyboard. Right? It's not like a typical MIDI keyboard. You're still losing something there.
I think this was a really educational talk. Let's give a round of applause for Calvin. feel free to meet Calvin like at the after event meetup and so the rest of the time. So.
Staying here till the very last talk. Oh, start. Okay. Yeah.
All good, right? Okay. All right, resuming the live stream. Okay, now we have the last talk for the day before my conclusion speech. So for the last talk, we have Vibhav, who is an open source developer who enjoys containers, audio, and running. He works at Red Hat as a senior software engineer, and his talk is titled ContraPunk from Palestrina's Rule to Real-Time MIDI Harmony. Please give a round of applause for Vibhav.
So thank you everyone for being here. So this is ContraPunk from Palestrina's Rule to Real-Time MIDI Harmony. So this project actually started off last year in Jain at the ADCx hackathon, where Abhinav, my teammate, had this idea, like, why don't we make something that uses like counterpoint to figure out what the person will play next, or rather like what harmony should be generated next. There are a lot of like harmony generators out there generally, like where you can just play something, figure out like what intervals you want to put on the keys that you're playing, and it'll just like generate those chords, right? Or like you can also like give styles. So the way we are going about it is generally to make sure that counterpoint is the main theory which we are going to use to generate the harmonies itself. Now, why we are using like a rule-based way of like going about this is because like we can just have like more deterministic output. Now in like today's day of like LLMs and AI is like, it's so easy to just give something and not get anything that like, you know, you want to like get deterministically every time over and over again when you play something. And this is slowly like coming to music with like Suno AI and everything. So this is kind of like an anti-pattern to that. Like we want something that is more deterministic, and hence this sort of like plugin will help us do that, right? So what are the 5 rules that we have that we make sure that we follow when we are generating a harmony? So whenever we are stacking harmonies on top of the pitch that we're given, we make sure that we follow the basic rules, which is like we reject fifths or octaves because they are kind of stable. We want things to be interesting. We want the stepwise motions, the contrary motions. We don't want any dissonant notes, like something that's out of the scale. And the last thing to reject voice crossing is basically we just want to make sure that you know, whenever we are playing something, it stays in that register. Like if I want to continue playing something in the bass, I will play something and everything will be generated on top of that. So before actually go ahead, I would like to just show you a little bit of a demo of what that looks like. So here we have ContraPunk running. And if you can see over here, the input is MPK Mini. So I have a MIDI controller here. Then the outputs are 4 IEC drivers, which link into, which like are directly feeding into this logic instance. I'm not good at logic. I just know how to like route this stuff. and just get the outputs that I need. And the only thing I'm looking for over here, I just want things to sound good. Whatever I play, it should just generally sound good. And I'm no Bill Evans. I can't just like take some melody which is like out of a key and like play something on top. I'm no like jazz pianist to like do that. But I want to be able to have the power to do that, right? So this kind of like helps me with that. So if you see the rules that I've given here, so lo-fi is a preset here, which kind of set things in motion. So here I've given B flat as the key, because the backing track is going to be in A sharp or B flat. Then strict is the strict counterpoint rules that we are going to follow. And you can see that we are in A sharp minor. So you can see that I've chosen this key there. Now in the keys itself, you can see that you can see that there are these keys which are like marked in yellow. So it's the 3 black keys, C and F, I think. Yeah. So F and like F, C, and like all the black keys basically. That's the A sharp minor. Now what I'm gonna do is I'm just gonna go ahead and play. And what I'm doing in the video is basically just kind of like having a good time, listening to the music, just playing the keys, and just trying to make sure that things just sound good. So you can see that the chords that are generated, they just generally sound so good with the backing track. And I'm only playing the green note here. Over here you can see I can give multiple notes, and I can get the harmony stacked on top of that as well. So I'm just like messing around. So generally you can see like, it's able to generate harmonies which just sound so good given the scale. And the thing here is like, we can all like generate harmonies generally, but how do we make sure that it sounds good every time? Because if you could tell, there was like all the chords which came after the other, like they were sounding good with the chords that came before it, right? So that means like we have to make sure that those rules exist as well. Now, before we get onto that part, I just want to like tell what this is built in. So first of all, we are giving like live MIDI input over here. It has basically like we have optimized for performance. So this is built in Rust, and I also want to make sure that this is just generally available, so you can host it as well or run it locally. Then that's about it. I don't want to go too deep in that stuff. But apart from that, this is basically the landscape we are in right now. There are a lot of tools out there which you can use for different aspects of this. But there is no one tool which kind of like helps you generate the harmonies like live and with like performance. So this kind of like goes into that. Now, how does this work exactly? Now, when this works in 2 modes, so when we were basically building it, what we needed to do first is make sure that the harmonies are stacked on top. So that is a stateless mode, right? You just need a basic like key, like your note and the key, and then like what to generate on top. But in a stateful mode, when you need to be aware of like what's already run, you kind of need to keep like a history, sort of like a sliding window of the intervals that have been played, and the ones that need to come through will come after. Contour is basically showing if the notes need to go up or down. So this basically helps with that. Then what happens is when you're generating these notes, there are a lot of notes to choose from, and there are like close to like 300 notes after you like play one note, and like based on the scale you've given, like you have to choose from all of that. And then after that, like 3 more notes will be like stacked on top. And that will be based on how many MIDI outputs you give. You can give like more than 3 MIDI outputs. Like if you saw the IC, like IC output over here, you can see that the voice 1, voice 2, voice 3, and voice 4 is there, right? So what is happening here is the note that you're playing is directly getting routed into voice 1, and then the rest 3 are like built on top. So you can see that sometimes it will omit a note, it will not generate it if it does not make sense, or it does not make sense based on the rules, because just having 4 notes at all times doesn't mean it's always going to sound good. Sometimes you need to like have less and then like create space. So you kind of need to think like go about that in the music writing also generally. So this kind of follows that as well. Then this is what the rules generally look like for each of the different styles that are there. So if you see over here, in the voice leading, I've chosen Bach. So it will try, whatever notes it generates, it is going to generate as if like Bach tried to like, play the harmonies themselves, himself. So this is kind of like showing that. Now you can see that in Palestrina and Bach chorale, we are rejecting the parallel motions completely. And then as we are like moving to jazz, parallel motion is fine, but like we get a penalty. And free is like, we just like allow whatever. So free is actually the first version we came out with to like test out. So it was very random, like, you'd play something else that wouldn't sound good would get played one after the other. And it all sounded very all over the place. And it's actually thanks to Deo at Riffle, who kind of like helped me out with this, because he wanted like the notes to be played, like he wanted the registers to say where they are. Like if I'm playing in like bass, I want to continue playing in bass. So if you go back here, down here, you can see like voice, right? So if I can, so if you can see down here, you can choose the voice that you want to play. Like I can choose to play the bass and all the harmonies will be stacked on top. If I can choose to play the melody itself, if I'm like good at playing piano, I can do that. I would be able to do that, but I usually choose bass because it's easy to keep like a bass line and then let everything like get generated on top, right? So this kind of also shows like how the stateful and the stateless works, right? In this case, like we need to have a state machine which keeps a check of what intervals have been played and like what the contour needs to be. So one thing is that we need to make sure that this is determinant enough. So the system makes sure that whenever you play the same thing, you get a deterministic output based on what's already been played. So because it's heuristic, everything that you play, like you can probably make the same thing happen again. Like there is one thing I do when I'm playing around with contrapunct is, I'll play the same note over and over again, and it'll just like change the harmonies. It's like how Bill Evans used to do it. Like he'd like play the same like 2 notes and like change around it. I don't know how exactly that works, but that's where like I wanted to like get into with the generation itself, because even if they are not thinking about the rules, there are some rules like that are being like applied like subconsciously at least, right? Then we've also added modal interchange. Basically, you should be able to do modal interchange, but this happens on a level where you can choose how far do you want to go away from the key that you're going. So this is something that is also supported. Then there is a humanizer. This is kind of still in the works. It's there, but it's a bit broken. I would suggest you to try it. So one thing that is really good is like sometimes when you're like playing your instrument, you want some humanization to be there. You want it to sound like someone's playing it. But I think the current problem that we have is the outputs are a little too random. So they don't sound like the same person is kind of like playing the instrument. So we're still figuring out on like how to work on that, and how to make it more human generally. Then yeah, this is something we already talked about. This is the constraints that we have for each of the different styles. Yeah. And we also talked about the determinism. So after we are done with everything, we need to make sure that the determinism is on point. So we also have a fallback mechanism, which is a lexicographic MIDI ordering, which makes sure that the MIDI is ordered based on, it's basically like in a dictionary how everything is ordered like one after the other based on like alphabetical order. This is kind of same, but this is for MIDI. So now, as I had told before, we started off in ADCx India Music Hackathon, and kind of picked this project up, and it kind of had its own life also. Over the last year, I also worked on another version of this, which is node-based like MIDI augmentation. So whatever we already had, but more like in terms of like nodes, I try to see how this would work in a more Lego-like way, where you just combine things together and try to make the rules. But it got a bit hard because I had to figure out how to do the UI and the backend. So I went back to the old method for this. Now, yeah. So thank you for just coming for this talk. And there is more to come, obviously. So the next thing I'm working on right now is the machine learning aspect of it, where I want to convert my guitar signals to MIDI. There are tools already out there for it, but this is something I want to build for myself to so that guitar is my main instrument mainly, and it is what I want to use my guitar with ContraPunk so that I can do all of this cool stuff and just jam along with ContraPunk through my guitar. And the only thing stopping me right now is guitar to MIDI conversion. So that's the next thing I'm actually working on. But feel free to contribute. The project is open source. It's on GitHub. It's under my nickname Wavy Waves and under ContraPunk. Do check it out. And thank you for being here for the last talk. I hope you enjoyed the demo as well. Thank you so much.
Thank you, Vibhav. This was like a full circle kind of moment.
Yeah.
ADCx India 25, we also usually do hackathons. I'll talk about that in the conclusion speech. But we do hackathons, and they started building a project. And very often we see that people would not pursue that after those 2 days are completed. But so nice to see where it has reached. This looks amazing. Let's take some questions.
Thanks for the talk. How's the keyboard instrument you built different from Scalar 3?
So I don't know how much different it is, but what are the similarities you're seeing generally?
I mean the bark thing and all, except that I feel
But the other harmonies already pre-generated there? Yeah, so this is not pre-generated. This is, builds them on the fly. So there is no storage as such. It's just a processing engine. Yeah.
Thank you.
All right, anyone else? Any questions?
Not a question, but I'm also quite interested in the guitar part. So I have worked with building a guitar where we experimented with the GK2 pickups and then with Fishman triple play. Both were successful, and I was able to even program them to work with extra guitar strings. Instead of 6, we managed to get them to 8. So maybe something to explore together.
Yeah, I saw that, man. I was just do I want to pay for pickups to
No, but the idea behind it can be replicated.
So that is a hexatonic pickup, right? So it would be cool. I don't mind chatting after.
Yeah, cool.
All right, any other questions? Okay, I have one quick one.
Yeah.
Why Rust?
Power. Speed, basically.
Yeah, that was not a question. It's kind of known. So.
Yeah.
All right, thank you so much, Vibhav, for an amazing talk. Round of applause for Vibhav, please.
Thank you.
Okay, all right. How was the event so far, everyone? Nice. So we are at the conclusion. I will try and tell some stories and some details about what we are trying to achieve with this. The only thing is that my notes are not visible to me, so I'll see how much I remember. First, the story time. And the duh is for people who have attended ADCx India before. The conclusion always has a story. So this time I forgot the story because my memory is not very strong. But I think it was along the lines of what we are trying to achieve here. I think many of the talks resonated with the idea that somebody is doing something very unique and very fresh that many other people want to know about but don't know about. Right? That's the common story, everything. Calvin is talking about the devices that he explored. Vibha was talking about an instrument like all the MIDI generation and stuff, and all the talks that have happened so far somehow resonated with us because even though we did not think of those ideas, somehow we liked that, right? So we started out ADCx India, the planning of it in 2022. Then we made a team and like we built upon things and we said, okay, let's do it. And then we did it in 2024. And we had a decent turnaround, like we did not expect it. And since then, since ADCx India 24, many people switched their job lane. Like they moved from IT to getting into music tech. They got internships by meeting people at the event. Some people even made their own companies. There are startups in music tech in India now. And that kind of was the story of 24. In 2025, we continued that. We thought, okay, let's maintain that momentum. And all that focus towards India just kept on growing. And it grew so much that now it's Avid and Global Logic and big names sponsoring us as well, right? So the idea is, where do we go next from here? Like, what's the next step? And that is what I was talking to Ajay about. Ajay, are you here still or have you left? Oh, okay. Can you please stand up once? Okay, so please give a round of applause for Ajay. And that is because after ADCx India 25, I was exhausted, like completely burnt out, because when we say that this is a not-for-profit event, we are not just using keywords. It's a not-for-profit event. I don't get paid anything. Anybody volunteering doesn't get paid anything. It's completely an initiative because we want to be the change we want to see in the world, all that philosophical stuff. So when we have to work on it, it's always on after working hours or on the weekends. And when you have to host like an event where you're aiming for scale, you have to find people in different corners of India because we don't know where they are. So it's like it takes a lot of effort, and that burnt me out. And then after the event, Ajay's message was, the third time is the charm. And I was like, okay, we have to do it again next year. And that was the seed of the idea, and that's why this year the event happened. Otherwise, frankly, it wouldn't have. So again, shout out to Ajay for it. So we discussed, we were just having a conversation before, during the break, and he gave a very nice idea that our next goal should be, so the first ADCx India was about setting up an ecosystem. Last year, the theme was momentum. This year, it was scaling up because now we have many numbers. And for the next year or the time that comes in the future, the goal is sustainability. How can we do this in a way that doesn't become a bottleneck for one person, or one person having to do things, or few people having to do things, 5 people, 6 people, and all that? And how can we have a very clear and open call to action to let people contribute, be a part of the team? So when after the event, an email will go out which have the feedback form. It will mention, like, you can anonymously tell what you like, what you did not like, be very frank about it. We take all the feedback very seriously. Like, for example, for the first year, our ticket prices were really high. And then people said, if it was affordable, it would have been better. Next year, we reduced it further. This year, at least 70% of the tickets were sold at early bird or free. So a huge amount of tickets were given away to diversity candidates, to people, and anyone who we thought, okay, is really interested and deserves to get a ticket, and financials are the only issue that is blocking them, we just gave the ticket to them for free, and that was possible because of the sponsors. I'll get to that in a bit. But what I'm trying to be very openly say as a call to action and be very vulnerable about this as well, because I don't mind if you see my flaws and my problems, but I can very honestly say that it takes a lot of effort to build, and maybe I'm not capable enough to do it at a larger scale. Like if you want to take this event to 500,000 people, I cannot do it. I can very openly say that. So if there are more people who join the team, who contribute, we will make it happen. And then we'll have more companies coming towards India. Maybe we'll form our own ones. But all the talks that we have in every conference about how Carnatic music and Indian classical music does not have representation in MIR and in like DSP, we can change that, right? Why do we have to just talk about it at every conference after conference and not have any solution, right? So the only way to change it is to join the, what's it called, motion or inqilab, I don't know what's the correct word, the revolution maybe, I don't know. So that's the whole thing. I want to keep it short because I'll want to leave a lot more time to you all for the after event meetup. But that is what is next. The next is us trying to find a team and make the event sustainable so that this does not just become once in a year thing where we meet, but rather more constant thing. And again, I don't care about my resume. I'm not capable enough to do it at a bigger scale than this, right? So I have reached my limit and I can completely see that. So please join and look out for the email that I'll send after the event. So now it's time to thank a lot. And I think you'll have to clap, I think, the whole time because there's a lot of clapping required now. I am from Soundly. I am the CPO of Soundly, a sound effects platform, not a plug, but just so you know. So I really wish I had microphones to record the clapping because it's I can sell it then. But first thing, thanks to all of our sponsors. So please give a round of applause to our sponsors. So a special shout out to Rajiv Arora from Avid. He could not make it to the event. He's based in Europe. But he's the one who initiated the idea that before we even announced the event, he reached out, is Bangalore ADC happening? And that's when we got the confidence that we might get some budget, which is why the ticket prices and all were low. And we also have after event, a lot of things we were able to plan because of his one email. And then he spearheaded the entire initiative to make sure that Avid and Global Logic come together and sponsor us. So a huge shout out to Rajiv Arora. Also, the entire team of Avid and Global Logic who have been educating a lot of people through their booth. So it's not just the showcase of their products. It's actually very educational if you are someone who don't know how film music is mixed or film post-production is happening, or if you have a favorite song, maybe you never knew which software were used to record it. Now you know, now you can see it. So it's very educational and it's really good that they have done a booth setup there. Then we have JUCE and PACE. The core reason ADCx India is happening and will happen, it's because of JUCE and PACE. Bobby Lombardi, the chair of ADC from PACE, and Tom Poole from JUCE, they have been really supportive. Andrew from PACE, Derek, all of them, when I first pitched the idea, I think I told you when we were not recording and people had not come back from lunch. That was not a joke, that at ADC 2022, we had the social mixer at a bar, and I just told them that I really wish this was happening in India. And all they said, yes, let's do it. And that's how it started. So it just took a very easy yes from them, and then this is happening. So a huge round of applause for both JUCE and PACE. In case you don't know, JUCE is the open source framework to make audio products. So if you have to get started in audio products, you're most likely going to start with JUCE. And PACE is the anti-piracy company that also now works with various other companies for software license protection and all that. I'll get to the JUCE learning part in a bit. But then let's also thank our other sponsor, Vinjay. Vinod, are you around? Oh, Vinod is here, finally. Big round of applause for Vinjay and team. So an interesting trivia. Vinjay, win means win, W-I-N, like winning. And Jay is a Hindi word which also means win. So the core philosophy of Vinjay actually means win-win. So the whole idea is that they have a win-win relationship with their clients, and I think it's a really nice philosophy. And we had a really good time to collaborate with them, because if they had not sponsored, we wouldn't be able to give so many diversity tickets. And I think it's because of them that we were able to make sure that the event runs smoothly. So again, thank you so much for being a part of this. And then lastly, we have FOSS United. FOSS stands for Free and Open Source Software. It's a community that does events all over India. They have meetups. I think they had a meetup in Bangalore yesterday. They'll have India FOSS 2026 event in September. I'm giving a talk at FOSS Lucknow next Saturday, introducing the FOSS community about music tech. So just go to fossunited.org, and you'll get to know a lot of events that are happening in your city, especially if you come from other place into Bangalore. And anything that you want to get started with, and not worry about the finances, FOSS is the easiest way, right? If you want to get into machine learning, not worry about whatever is required in machine learning in terms of premium. FOSS is where the solution exists, right? So please check out fossunited.org, and a huge shout out to them for helping us with the sponsorship. All right, so if you're getting started, this Milap also had mentioned, Jan Milchek has created this course to learn JUCE for free. It's available on wolfsoundacademy.com/JUCE. This is getting live streamed, so you can always check the link later as well, or if you want, take a picture. Before I go here, okay. All right, so now it's also time to thank all the speakers. Please, let's give a round of applause for the speakers. I specifically want to mention that this year we got the best call for talks entries so far, and we really could not decide which one to reject. Like, if this was a 2-day event, almost all of them would have actually made it. So just for anyone whose talk did not get into the list, what is written in the email is not just for the sake of writing. We do mean that you should apply for other ADC events in the future, maybe ADCx India in the later time as well, because your talk has a lot of value. And I think as long as we can fit in the schedule, we'll actually be able to accommodate those as well. So again, a huge thanks to all the speakers and to everyone who could not make it but is also doing great work. All right, this I have not told them that I'll do, but I will do it. Because being the person who is leading this, it's just me who people get to know. And it's not a good thing, because people really need to know about who is actually running the show. So I would like to call the organizers on the stage. So please keep clapping as we bring in Charulata Mohan, Pradeep Matthew, Vedant, and I'm already here in a way. So can you little bit turn the frame so they can also be seen? Please. So, like, when you have to do project management and stuff, you have a lot of headache. I don't like people management. I'm just saying it very out loud. So Charulata was the reason why the event actually went out smoothly. All the project management, making sure everything goes on time. If you have got emails from us, and if it is structured, it's all her, making sure that all the information is there. Everything, all the edge cases that can be thought of, it's all Charulata. Pradeep has been helping us since the first ADC, making sure that all the logistics, every attendee is happy with the requirements, and he is like, if anything is required, and if I have to immediately get a solution, he's the one I call. Vedant, anybody who does scuba diving here? Anybody interested in scuba diving? He's a certified trainer, and he travels the world scuba diving and seeing the world underwater. And the other thing that he likes above water is this event. And so Vedant is the one who has been helping us the entire tech. So round of applause for the organizing team. Thank you.
We can't forget Prashant.
Yeah, it's okay. Yeah. All right, so now it's time to also thanks volunteers. Here's the thing. I don't want just people to be known by name or designation. I hate designations, frankly. I don't think that if you are a CEO, you are any better than a junior sound designer, because to become a CEO, just make a GST registration and you're good to go. So that's all it takes. Or rent a shop, you're a CEO already, right? So I don't care about things. So what I do care about is you get to know people for what they are, like the real persons. So I will try and tell you about all the volunteers as much as possible because I only know them for the last 1 week. But how much ever I have been able to grasp, I'll tell. Okay. So please come on the stage as I take your names. So Suswara is the one who is running music tech initiatives at IIT Chennai. Like she hosted an event called Beats and Bytes along with Kratika Jain, who was a speaker this year. And they have been making sure that while they learn, they also let other students get to know about the music tech community. Then we have Shruti, who is a PhD student. Shruti, where you are? Okay. She has been exploring music tech. She's interested in music, but she was not sure what this domain is about. So she has just been trying to meet and understand and grasp what's happening and meet the speakers. Then we have Chandra, who has also been exploring music tech as a student. Then we have Anirudh. Where are you, Anirudh? Anirudh is a sound person. He has been helping us with the sponsors, interactions, and everything. Then we have Dayanidhi. Fun fact about Dayanidhi, Dayanidhi gave a talk last year at ADCx India. And if you see the live stream video, you will notice that he was a bit nervous because I'm assuming it was his first stage event and all that. And I'm seeing him this year, and the confidence level is just reached somewhere else. So again, I really appreciate this. Great. And then we have Guru Prashant. Guru Prashant is also a student who has been exploring music tech. They are both studying together, and they are like, I think, best friends because they're always together. So again, round of applause for all the volunteers. Thank you. Yes, for sure. Okay, so now, Girish, can you set the frame the way it was, like with empty space, little bit? Yeah. Okay. There is a reason why we live stream this video, this event, and this is a question that a lot of people can ask, like, why is the in-person ticket have a cost, but the live stream is free? And that is because I'll actually talk about that later as well. If you can find us a venue and a catering that is free, the tickets will be free, as simple as that. The reason the live stream is free is because the whole goal is the two main points. First, make sure that the knowledge is shared to everyone for free. That's the reason we live stream it and upload it later on. Secondly, which is also equally important, to give visibility to the speakers and also to the geography from where those speakers come, right? And that's how we make visibility and get known in the world, right? So those are the two reasons why the live stream is free. And it wouldn't be possible if not for the live stream and recording team. So I would like to call on the stage the entire crew. Ganesh, please make sure the live stream does not break and slowly come. And Girish, please make sure that the camera is proper. So please give a round of applause for the entire team. Ganesh, Girish, and Anand. Please, please, please. We only have limited time. Yeah. So the other Prashant, he couldn't be here because they actually have a live stream company. So he helped us set things up yesterday. He made sure everything runs properly, and then he's taking care of the other event. So I wouldn't say he doesn't love us as much because last year he was there for us for our event, but then this time the crew is here. So again, a round of applause for the team. All right, thank you. All right, so thanks to the supporting team as well. Alician is basically our finance partner. Everything that has to be paid and all that, sponsorship coming in, the money has to go somewhere, right? I cannot take it. I don't want to pay so much tax. So it goes to Alician, and they are the ones who help us. So Sandeep, Prakash, Mukul, and the entire team has been really helpful to make things very smooth. So a round of applause for them. I told you there will be a lot of clapping. And then, how was the food today? Okay, was it great? Yeah, I know. So I know it because last year we had the same caterer, and they were so good. And I couldn't eat lunch, by the way. I made the biggest mistake of my life. So this year I had lunch, and I really enjoyed it. And because they are so good and so professional in everything, we just wanted to collaborate with them again. So shout out to Akash, who is the manager, and Himanshu and Susanta, who are the cooks and the servers, and the entire team. And then we cannot stop without thanking the BIC team. Saraswati is the one who has been managing the entire event, helping us make sure that everything is available on time, whether it is the auditorium, the spaces, the tables, and everything. Savana is the one who is there right behind us. He's taking a quick picture. He helps us make sure that everything, the tech, runs properly. And Jibin was the one who was there in the morning, handling that part. He's not here right now, but again, he has been a really big help. So entire BIC team has been really helpful, so big applause for them. Thanks to the ADC team as well. Bobby is the chair of ADC. Tom Poole is the director of JUCE. So if you want to directly connect with him, just let me know and I'll somehow ask him, or just email him directly and he'll reply to you. Andrew is again the person who we met at the bar and he's like, yes, you should do it. Ralph is the designer. All the logos, all that flower and all that you see, the t-shirts, we have been consistently using the same design. We have not changed it because it's so good. It's been catching on. Like it's come into fashion in a way. And that's all designed by Ralph. Derek is the one who runs the ADC mentorship program. I'll talk about it in a bit. Sophie and Jim are the ones who run the main ADC India event. And they have been like the core reasons why ADC has been running for the last 10 years, and this will be the 11th one. So a round of applause for the entire ADC team. All right, so and a huge thanks to all of you for joining us in making sure that we are able to build and scale a music and audio tech ecosystem. Like I said, my limits have reached, and I'm very openly saying it. I don't care about my resume. Please come join us. We want to keep this momentum going, scale things up, make it sustainable, so please be a part. Looking into the future, a quick note about the ADC mentorship program. Every year around April or May, what we do is through the ADC newsletter, we send out a form to all the signups of the newsletter, right? And we ask people who want to get mentored and people who can mentor, right? Mentees and mentors. They will sign up, and then all the mentors have to do is 1 hour call 3 times in 6 months. That's it. So you just schedule 3 calls over a span of 6 months for 1 hour. And that way you are able to guide new mentors. People are there who want to understand, should I do a master's? I'm a student like just in school, should I take a bachelor's in music tech? Which school can I join? All of that. And if they are professionals, if they want to switch careers, which companies can they prefer and what skills should they learn, right? So all of that happens, and this is all free. Now the problem is, every year we see more people sign up to be mentored as compared to people who are ready to help. So matching is not always possible. We cannot have one mentor like 10 people, right? Because they also are contributing the time for free, right? So what we want all of you to help us with is, if you can mentor someone, please sign up as a mentor. It can really change someone's life. You have no idea how many students and professionals have been able to upgrade their lifestyles and do things that they really wanted to do because of this program. So please scan this QR for that. Now, how will you get notified about ADC events? audio.dev/newsletter. I know this is the world of social media, but newsletters still are the official source of all the information. So please sign up to the newsletter so that you are informed of what's going to happen next and when the mentorship program goes live. This talk is being live streamed right now, I hope, nothing broke, on the ADC's YouTube channel. Anything related to ADC will have the handle name AudioDevCon, the hashtags, the @ on all platforms. So this is something that you can make a note of. Next steps, send us your feedback. Like I said, we read every note. We have reduced the ticket prices. We'll try and do more things. Help us find a venue. And I'll tell you one very frank thing, okay? Because there are 2 things, the way finances work. Okay, I forgot to mention one thing in the start, which is running an event is like starting a startup whose deadline you are aware of, whose expiry date you are aware of. Like today is the expiry of ADCx India 26, right? So what happens is, if we have to consider cash flow, like money coming in and money going out, we can make a decision of what we spend money on. So we can either spend money on the venue where the pricing is very high, but that would mean that we have to keep ticket prices high. Or if we get a venue for free, like in a university, for example, the money that comes from sponsorship can actually go to help attendees. We can give honorarium to attendees. If there is a speaker coming from, say, very far in India, we can somehow help them with their travel, their flight tickets and whatnot, right? So what we want to also do in the future at some point is to use the money to help people rather than to have it as expenses. We love BIC. I think this is something that we'll continue to do so. But if we can figure out a way that we can have less, like reduce the cost in some way, just please reach out and we'll be able to have a conversation. The pictures and everything that you took today, please post on social media using the hashtag AudioDevCon. Will you remember all this? Yeah, but who watches? Like, if you have given the exam once, why would you go back and remember the questions and all that? Okay, if you want to forget everything else and remember just one thing, when you're posting on social media, tag ADC pages and use the hashtag AudioDevCon. Everything else will follow, okay? Yeah, so this year, what else is there from ADC? ADC 26 is happening in November from 9 to 11. One important thing for all of you, the main ADC event has a hybrid format, meaning you can be a remote speaker as well. Like ADCx event, you have to be an in-person speaker. But if you are not able to travel to Bristol, that's completely okay. Apply for the talk. If you have a decent idea, maybe you're not confident about it, the worst that can happen is a rejection, which you were anyways prepared for, right? Like if the idea was not good enough. But give it a shot, apply it, because many people here in this room have also given talks by being in India, and they have actually also upgraded and gotten more projects because of their talk there. Yeah, we have sponsorship slots and diversity grants available, but that's something that we can check later. And before I just wrap, I want to tell one quick story. Is Daniel around still? Daniel, can you please stand up once? Can we please give a round of applause to Daniel? So Daniel was the speaker last year. He is a student. First of all, I have to be envious of so many people. He's a student and he built a thing called MIDI FX. He presented that last year at ADCx India 2025. And then once the video got uploaded on the ADC channel, he got reached out by somebody from Greece who liked the project and they are now collaborating on it. So he mentioned to me on LinkedIn, like in a message, that one thing that he realized is that these events have value even once they have concluded, because you never know when the information reaches the people that it's supposed to reach, right? So I think the story is like Daniel says what we are trying to create here. So again, a big congratulations to Daniel for doing that project and for helping us be known everywhere. Thank you so much. So that is where we wrap the event for the online audience. Hey everyone on YouTube, you will see a promo video of our sponsors one more time before the live stream ends. So thank you so much for being a part. Let's all in the audience give a round of applause so we can conclude the YouTube stuff.